At the end of 2017, a galaxy 236 million light-years away began a rare and dramatic transformation. It's an event astronomers are still puzzling over, one set off by changes near its central black hole. They first explained this as a tidal disruption event. That's when a star wanders so close to a supermassive black hole that it's torn apart. A new study of observations spanning the entire event suggests a different cause. The trigger may have been a flip in the magnetic field in the disk of material around the black hole. The Sun's magnetic field reverses polarity every 11 years. On longer timescales, even Earth's magnetic field flips. Starting in December 2017, the galaxy began to brighten in visible and ultraviolet light. The source of this brightening appeared to be the disk of material around the supermassive black hole at the galaxy's center. It peaked 3 months later at nearly 100 times its previous brightness. That's when regular monitoring with NASA's SWIFT satellite began. As the visible and UV brightened, X-rays from the galaxy dimmed. By August 2018, the higher energy X-rays had disappeared completely. A few months later, the high-energy X-rays came back, even brighter than before. They returned to normal within a year. These X-rays come from a cloud of super-hot particles near the black hole. It's a feature called the corona, which is formed by the strong magnetic field. The lack of higher-energy X-rays means that this structure was essentially gone. Based on observations from SWIFT, Europe's XMM satellite, and ground-based optical and radio telescopes, here's what may have happened. The visible and UV flare results when the flow of matter into the black hole increases. This may have started when the magnetic field in the disk's outer regions began to flip. The weakened magnetic field can no longer support the corona, which vanishes. The flipped magnetic field gains strength, restoring the X-ray corona, but the inward flow of matter is still high, so this emission is stronger than it was before the flare. Finally, the corona and disk return to their states before the flare, now with a flipped magnetic field. Rapid changes in UV and visible light have only been observed in a few dozen active galaxies like this one. But this is the first time X-rays have been seen to drop out as other wavelengths brighten. These surprising events offer a tantalizing glimpse at the extreme forces at work near an actively feeding supermassive black hole.
Well, hello everyone, and welcome to the 150th Global Star Party. I'm here with a bunch of people backstage and our co-host, David Levy. And can you believe it, David? 150 of these things. It's been amazing.
Yeah, it's been really very, very special. And I still remember that time when you called and said, I want to put on this event called a Global Star Party, and I'd like you to come to each one and recite a poem. And 150 times later, I'm still doing it, or trying to.
Yes, you are. Yes, you are. That's right. And we've had some amazing people on over the years. You know, the whole project was started to, you know, bring people together during our pandemic lockdown. And you know, through those years and the, you know, our audience participation and different people, I learned that there were other reasons why astronomers are sometimes in lockdown. You know, maybe it's just how remote that they might live, or, you know, they're caring for somebody, they're a caregiver, or they may, be physically challenged somehow to not be able to get out. But through Global Star Party, they've been able to connect with many luminaries in the amateur astronomy world, in some cases the professional world. We've had people like Alan Stern from New Horizons on this program. We've had Dr. Linda Spilker from the Jet Propulsion Laboratory, actually several scientists on from the Jet Propulsion Laboratory. We've had scientists on from other institutions as well. So Jeff Weiss says my audio is low. How is that? Okay, so anyways, and we've done, we did live presentations. All of this is live. David Levy hung in with us for 24 hours straight one time when we were doing the Great Conjunction around the world and all of that.
I'll never forget that.
It was amazing. So, tonight we have, at least a dozen presenters to come on tonight. And some of them agreed to come on even with their very tight schedules. And one of those people that has an extremely tight schedule is Professor Kareem Jafar. And Kareem he's done many global star parties with us, including one that we did for Astronomy Day, where we actually got Doug Berger, who created Astronomy Day, on that program. So he was a little difficult to find before, but he did agree to come on with us, and it was just spectacular. I'd long wanted to meet the person that started Astronomy Day, and that kicked off the Astronomy Week and Astronomy Month, and now we have 2 Astronomy Day type of celebrations every year, in the spring and the fall. So anyways, Doug, if you're listening or if you watch this later, we are all wishing you well. And so Kareem, I'm going to have you come on, and let's
after David, though, right?
We can do David first. That's right. That's
Okay,
right.
all right.
That's right.
Okay, I will be
How would I forget that? So there we go.
I will be a little bit quick tonight because I'm anxious as you are to hear what Kareem has to say. But my poem tonight for the 150th Global Star Party is, and you might have guessed it would be 150 bottles of beer on the wall, but it's not. It's from a book called West Running Brook that was published in 1928, and it contains poems by Robert Frost. And the section that I'm quoting from is "The Lovely Shall Be Choosers." And there is a poem in that section called "Acquainted with the Night." Turns out it's one of his most famous poems. I have been one acquainted with the night. I have walked out in rain and back in rain. I have outwalked the furthest city way. I have looked down the saddest city lane. I have passed by the watchman on his beat and dropped my eyes, unwilling to explain. I have stood still and stopped the sound of feet when far away an interrupted cry came over houses from another street, but not to call me back or say goodbye. And further still, at an unearthly height, one luminary clock against the sky proclaimed the time was neither wrong nor right. I have been one acquainted with the night. Thank you, and back to you.
Very cool. That's a great poem. Wonderful. Okay, all right. So being that you and Kareem have long known each other, do you want to introduce Kareem? And
yeah, I would be very honest to do that.
Yeah.
I've known Kareem for many years. He is right now one of the most active people in the Montreal Center of the Royal Astronomical Society of Canada. And I know that group very well, intimately. It is the first astronomy club I was ever a part of, and it remains my favorite astronomy club, despite the fact that in 1967 I was almost expelled from it. Maybe one of these times I could tell you about that, but it's become really a legend and quite a neat story. And every time Kareem has something to say, it's really interesting, original, and exciting. So, Kareem, it's all yours.
Oh, thank you, David.
Yay.
I don't know that I can live up to that, but I'll try my best. Hi, everyone. It's great to be back on the Global Star Parties, and it's fantastic to be celebrating GSP 150. I try most GSPs to talk about something on topic, and I'm actually going to break that mold today to some degree because Scott put me down as a Rask update, and I actually have a few things I want to talk about that we've been doing up here in Montreal because it's been a little while since I've been on a GSP. And there was a total solar eclipse, there were a couple of other neat things happening. So I want to share with you a little bit of what we've been doing up here in the Montreal Center. And I also want to highlight a few things for all of the other outreach volunteers, educators, coordinators out there in our audience, because I find every now and then we come across a neat trick or a neat tool or a neat idea that we share amongst our community, and everybody gets to benefit from this across the world. So as always, I'm here at John Abbott College in Montreal, Quebec, Canada. I'm the physics prof here who teaches the astronomy course, but it's only in the fall, and for the rest of the year, I'm the outreach guy. And I'm currently just at the end of my term as an honor science coordinator here, and you got to hear from a few of my honor science students last time I was on a Global Star Party talking about the ISS Mimic project. But what I want to talk to you about today is a little bit of what I've been doing with the John Abbott College Space Club. I do want to mention within my other outreach areas, the lowbrows, which I share with Adrian Bradley, who's an astrophotographer on the GSPs often and who will be on later tonight. But on Space Oddities, that's a show that we have every Tuesday afternoon that is based out of the UK at 8 o'clock UK time, which is around 3 p.m. for us here in Montreal, 4 p.m. Or 2 p.m. Central Time. We just celebrated our second anniversary today. And I can't go without saying anything about the ever-changing cosmos. And in our second anniversary today, towards the end of our discussion, we were talking about what we're looking forward to. And we had already talked about our best news stories of the past 2 years, and we mentioned James Webb, we mentioned the return of OSIRIS-REx from asteroid Bennu, we mentioned a few of the other launches and some of the amazing work being done by the Event Horizon Telescope. But looking forward, one of the neat things that will help us to understand the ever-changing cosmos is the newest images that came out of Euclid and the soon-to-be first images from Vera Rubin. And we can start to explore soon, hopefully, dark matter and a little bit more from the observational perspective. And so I'm hoping later in the summer to give a bit of a talk on what we hope to see coming from some of those. But again, today I want to focus a little bit on what the Space Club has been doing here in the Montreal Center. And I always start with the land and sky acknowledgement, and we are currently on unceded Indigenous lands here in Montreal. But we also share the sky with our ancestors, our native peoples from across the world, and cultures from all times. And at the moment, we are in our waning gibbous phase of the frog croaking moon here in the east coast of Canada. And you can hear the frogs having their lovely serenades at night, especially right now in stormy season. We've had some really heavy storm rains the last couple of days. And the settlers would call this the flower moon. April showers bring May flowers. So we can always acknowledge a little bit of what's happening in nature when we look up at the sky. Part of that was really evident during the eclipse times because the legends of the eclipses really captured the imagination of the First Nations because all of a sudden something that was central to the sky appeared changed or gone, which was the sun. And our avid GSP fans might remember that we've been working towards this total solar eclipse event all year, and I was mentioning different things that we were doing in the Montreal Center to get us prepared for this wonderful event. We brought partners on board, we had all sorts of activities set up. And the Space Club itself actually began during the 2017 partial solar eclipse with a team including Emily Laflèche, who you've gotten a chance to meet. She's currently doing her PhD at Purdue in planetary science. Well, this year we had a huge team of students take the lead, and we were able to have an incredible experience with between 4 to 6,000 people with us during totality. And we gave out over 4,000 eclipse glasses that day just on site here at John Abbott College. And I would be happy at some point to share some of the images and some of the videos that we took that day. But what I thought I would share with you is some of the other things that we did that made it a different experience for us at John Abbott College. So the first thing was, at the last minute, I got a request from a comp sci teacher to set up a station so that they could do some measurements during the eclipse. So we had Raspberry Pis running different sensors, and we were able to measure the temperature change, the humidity change, and the luminosity of the sun changing around these sensors over this entire span. And you can see how the humidity spiked as the temperature dropped as you approach totality. And the neat thing is you can also interpret some of these dips because people were walking over to see what the equipment was and putting their head in front of the sensors, which only affected the luminosity. It didn't affect the temperature and humidity nearly as much. So you can kind of gain a lot of scientific knowledge. At John Abbott, we only had 75 seconds of totality, so we didn't have enough to do any of the larger scale experimentation that we tend to do around total solar eclipses, like looking for the effects of general relativity. But because we had the chance to do this measurement, it gave us some quantitative information that we could carry forward with us. One of the big things that we also wanted to do was find novel ways to share this with people so that they would benefit from the in-person experience of the total solar eclipse rather than watching it from home on their computers or on the TV screens. So we had a program, Arts and Sciences, build 3 pinhole rooms. And we had different patterns projecting the various partial phases in these 8 by 8 by 8 pinhole rooms. And then the students took turns giving these tiny little presentations about optics, about the understanding of a pinhole camera and the flipping of the image from what you're seeing to what you actually see projected in front of you. We had our astronomers themselves with hydrogen alpha cameras, with solar filters, trying to take as best as they could the capture of the entire iteration of this wonderful event. And then we had for kids these wonderful masks that were suggested by my colleague Chris Kerwin at Astronomy by the Bay, who we've had on our GSP about a year and a bit ago. These masks, the kids got a chance to decorate them. We stapled the eclipse glasses inside so that they would want to wear them because it gave them kind of this identity, this way to walk around and have those eclipse glasses, but be able to show it off in kind of a fun way. We also had, of course, our viewer stations to show with pinhole viewers, serial boxes, foil pinholes, to be able to do that large pinhole projection yourself in a small confined way. And then we made a community mural for the eclipse, which was led by our Let's Talk Science team. And then on the actual moment of the eclipse, I was really touched because my parents joined me. They traveled from Guelph, Ontario, 6 hours by train, and my aunt came down and they got to experience their first total solar eclipse right alongside me. Now, the total solar eclipse happened on April 8th, and a month later was my 50th birthday, and so my wife surprised me with the diamond ring effect on an eclipse cake, along with that sunset effect extending along the horizon.
Wow.
That, I thought, bucket list item off my bucket list. I've turned 50, this has been a wonderful year. And 2 days later, we get the Aurora Borealis extending through not just to us here in Montreal, but extending all the way down to Deauville in Arizona. There were views and photographs from Tenerife. There were photographs from South America, from places that had never seen an aurora before. And we got to experience this in such a degree that just driving along the highway, my wife was able to capture pictures of the colors of the aurora with the the very bright moon right there. And the bird structure, that feathery phoenix structure that we hear in the tales from the First Nations, was evident constantly throughout the night. There was this wonderful cloud that was kind of hanging around near the setting moon all that evening, and we were able to capture it at different moments. And I actually got this printed for my wife for our anniversary because I thought this was just such a beautiful landscape picture. And then I decided to spend some time looking north, and I was really gratified to see that even with my cell phone camera, I was able to split the double star and the Big Dipper while capturing the aurora there in the background. Now, this is all great, and the cell phone cameras could capture a lot when you took the pictures, But with videos of cell phone cameras, it's harder to do. And my wife's cousin was there with an iPhone, and she found this fantastic trick that I want to share with people, because with the sun approaching solar maximum, we may have more opportunities for aurora. So if you set your phone up in video mode, but with the long exposure camera setting, it gives you these previews of a 3-second or a 5-second stack. Now, if you go to press video, it's only going to give you that live image and you're not going to see very much. But if you keep that preview and you do a screen record instead, now you get that long exposure video with just a little bit of pixelation, but otherwise you get to see all the benefits, all the features of the aurora in the sky moving at real time. Now, this type of a video clip, when you capture it, you can then trim it. And once you've trimmed it, it looks like you've taken a long exposure with a DSLR camera and been able to actually even move it around and capture different parts of the sky, different parts of the horizon, and you can capture the entire auroral curtain. So my wife's cousin, Inara Tajdin, came up with this approach to use her iPhone for. And while she was doing this, I had my DSLR camera set up and I thought I was doing the great thing with the DSLR camera. But as you can see, I didn't get nearly as much impact or as much resolution and color as she did. Now, I was looking at a different area of the sky, admittedly, and you can still see some wonderful features here on this time lapse from my DSLR camera. But if you're out there and you have your cell phone camera, please do get that type of a setup with this preview of a long exposure, because you're going to capture some incredible movement. It's just like with the eclipse, having my parents there, having my family there with me for the aurora. This is what for me makes astronomy special, is having my students, having my family, having my local astronomers, my fellow rascals there with me. And we were about, over the span of the night, close to 150 of us going through this small car park area in Hudson, Quebec. Now, last Wednesday, during David's birthday, he joined us for our last public event of the spring, which is observatories. It was a talk of 25 years of visits to ancient observatories, and included Yerkes, which is here, which is on my bucket list of places to go visit. But one of the neat things that happened is our speaker, Daniel Provençal, was talking about the observatories in Tenerife and some of the ones that he'd gotten to see. And then he mentioned that he was there for the Starmus festival, which was just wonderful because he was there for either Starmus 2 or 3. And so then we started chatting about Starmus and this concept of music and astronomy. And so again, David already has mentioned this, but if you've never been to a Starmus, make it your point to go to the next one, because these are incredible events. Now, today I got a chance with my students to go and visit the Canadian Space Agency. And this will be an entire talk in itself sometime down the road. But I wanted to share with you just a couple of highlights to wet your tongue, to wet your palate about what the CSA has to offer. So this is us at the entrance, and there's construction going on. And so we weren't quite sure what the building itself looked like. But inside there's the flags of all the provinces and territories of Canada. And then when you look up, you actually see a view very similar to the window of the ISS. And then when you look down, you actually see a solar system pattern where you can identify different orbits, and the orbital spacing goes through much of the first floor of the building to represent the distances to the different planets, to the asteroid belt, etc. And so here's Earth at our third orbital planet there. When you look at the entire Space Center building, the John Chapman Center, it's actually built to mimic the International Space Station, and it's modular, so you can add to it at different points. So there's a spoke and wheel type of a setup where you can move out from that center cupola and move to different areas, and those different areas are structured in that way where you can add to them as time goes on. Now, it's right now in Canada, a lot of our focus is on our return to the moon, and then hopefully using the moon as a stepping stone to Mars afterwards. And the Canadarm and the Canadarm2 are some of the largest impacts that Canada has given to space exploration, as is understood by most of the world. But we have a lot of different satellites and instruments on telescopes that were featured there at the Canadian Space Agency. And the James Webb Space Telescope, we've talked about it before, and some of the cameras and instruments and the fine guiding sensor that were built here in Canada, in Montreal. Well, we were really fortunate because our tour guide today was Julie Claveau, who was the deputy program manager for the James Webb Space Telescope here in the Canadian Space Agency. So she was talking to the students about the way in which these types of projects are managed and all the different things that go into putting a telescope like this up into space. So I'm hoping down the road I can bring Julie on for one of our global star parties. We got to see the mission control where the Canadarm is actually used from the ground and where some of the cameras and the Dexter and the mobile service unit are all oriented, and the flight patches of everything that the Canadian Space Agency has been involved in with the International Space Station. And then we got to see the training room where astronauts from across the world come to get trained on using this Canadarm. And it's all three components of the Canadarm. Dexter, the little hand that you see there on the left, the large Canadarm, which is like an elbow, and both the forearm and the upper arm, and then the shoulder, which is the mobile service unit, which moves to different places along the International Space Station. We also got to see some of the testing grounds for trying out different aspects of rovers for future missions. And I actually ran into Dr. Farah Alibhai from JPL at the CSA today, who is one of the Perseverance robot drivers for the drone, for the rover that's on Mars right now. Then we got to meet David Saint-Jacques, who has come back from space during COVID and is now stationed out of the Canadian Space Agency. And so we got to have a little bit of time with him, and he answered a few questions from the students and then posed for this wonderful picture with us. This was an incredible experience. And as always, it's wonderful to share some of these things that we do at the Montreal Center with everyone. I also was incredibly fortunate because this is the last day that I'm seeing my students before the summer vacation, and they decided to present me with a mug that shows the logo of the total solar eclipse that was made by one of our exec, Evelyn Liu, who was taking a physics course with me. And then on the back, we have the logo of the Space Club, and all of the students who helped to organize the different aspects of the Eclipse event signed it for me. So they told me this was for my coffee, but I've got my coffee mug. I don't want to make this mug dirty at all. I want this mug to be there for posterity. So I want to thank my students, the John Abbott College Space Club, for making this an incredible year. And I want to invite anybody, if you're in Montreal at any point, you want to come to one of our events, just drop me a line. We'd love to have you join us, whether it's under the stars, whether it's in the library, or whether it's just for a chat over coffee. Scott, back to you.
Okay, all right. So let's bring back David Levy, and we will introduce our next speaker. Since
Wonderful.
both of you guys are RASC members, okay, and our next speaker is a RASC member as well. This is
I'm also a RAS member, so that makes four of us.
okay. So you got four.
We're starting to outnumber everyone else. The Astronomical League is going to have to be careful
That's
here.
right. That's right. But up next is Nathan Helner Mistelman, and what can you guys say about this particular young science writer?
So those people who've been reading Sky News when it was still coming out will have read, articles by David, but also these incredible witty cartoons and comic strips by Nathan. And Nathan has been a presenter on the Global Star Parties before a few times. He's now an accomplished author. He was here in Montreal for a book event just last month in between the Eclipse and the Aurora. And David and I have yet to have a chance to kind of sit down and pick Nathan's brain, but I'm hoping that since we have a published poet in David and a published artist and writer in Nathan, that we've got kind of the buddings here of a great mentorship or a cool, really interesting perspective book by two authors that would be wonderful to hear. David, have you had a chance to meet Nathan or talk to him at one of the General Assemblies?
Yes, I've met him many times on the Global Star Party, and really impressed with the work that he's doing. But most important of all is he's doing stuff that I wish I could have been doing when I was his age, and I wasn't. I was just being a lazy bum, essentially. And it's nice to know that there's someone in the next generation here, two generations away from me, who is really going to make a contribution and is making a contribution.
Absolutely. So without any further ado, Nathan, we're all yours.
Hi, everyone. It's so nice to be back on, and congratulations, Scott, on 150. That is fabulous.
Thank you very much. Thank you. It's really
Um,
exciting to have you back on. And I was reading a little bit about your new book. I'm going to have to get a copy of it. But tell us what's been going on in your world.
yeah, so it has kind of been dominated by the book lately. It's been a lot of sort of publicity events. I'm really excited today to kind of tell you about the story of sort of the contents of the book and what inspired me to write that. But Kareem, thanks for talking about the total eclipse because I was also in Montreal at the time to watch it. And that was amazing. We actually kind of divvied up the family because we weren't sure which location was going to get a clear sky or not. So my parents actually saw it from a different location. And we both did get to see the sun get blotted out of the sky. But afterwards, I was kind of asking my parents if they could tell me what they saw. And they said, no, son.
Ah,
But regardless, without further ado, I would really like to uh, just sort of talk to you guys about this project of mine, and it's called Cosmic Wonder. And this is the name of the book I've written. The original subtitle I wanted was The Scientific Guide to Having a Perfect Existential Crisis. However, this wasn't quite what the publisher wanted, and for good reason. But yeah, I don't intend to give anyone here an existential crisis, but that was kind of part of the waiver you signed subconsciously when you got onto this webinar. So without further ado, this is a story about the known and unknown universe. So it's taking what we know as scientific fact about where we are in the universe and then extending it into some speculation that to me is like a probably the closest I've ever come to being spiritual, just like appreciating where we are in the big picture. And yeah, so it kind of started a while ago when I believe I was 4, got completely obsessed with the scale of the universe and started drawing these posters with giant stars as like circles and then this little blue pencil dot on it that was meant to be our planet drawn to scale. And I would run up to my parents and I'd be like, Mama, Daddy, we don't matter. It's this epiphany of sorts. And that kind of trailed on to the rest of my life, just kind of this fascination with the big picture. So I had a chance to hang out at astronomy events. And when I was 10 years old, I joined the Astronomical Society, the Royal Astronomical Society of Canada. So I am a proud RASC member, along with many of you here tonight. Um, and so the first question I want to ask everyone is, what's up tonight? Because while this may seem like a mundane social introduction, what's up is actually one of the most profound questions I have ever asked. Because what is up? This picture I drew, which is one of the first illustrations of my book, is showing the way the Earth is tilted relative to the solar system at my latitude. And that is probably different for a lot of you here tonight. But that is what the inclination of the Earth is relative to the ecliptic for most of the day where I am. And for the folks in Montreal, that is also the same for you. And the idea for this book kind of began when I was 12 years old in 2020, watching a total lunar eclipse happen. And this was kind of like most other lunar eclipses, except for something that happened halfway through. The eclipse in 2020, well, we were watching around 11 p.m., and I had my telescope set up across the street from my house. And my friend was also watching through the telescope, and I was going to take a break, get something to eat. So I stepped away, went to get some cookies, and while I was walking to get some cookies, my friend like shouts, "Did you see that? Whoa!" Of course I hadn't because I was eating a cookie at the time. But he had seen a small flash on the moon's surface, and I did not think much of that. Could have been a hallucination for all I cared, until I looked at the news the next day, the next morning, and it's like right there on the headlines, asteroid impacts the moon during total lunar eclipse. And it turns out that my friend had been one of a few thousand people across the world to have seen a tiny flash on the moon's surface as an asteroid the size of a house collided with the surface of the moon, releasing the energy of tens of thousands of kilograms of TNT and exploding a crater the size of a neighborhood. And it was kind of cataclysmic what happened on the moon. Like if this thing had hit a city on Earth, it would have leveled a building and fires would have started and probably hundreds of people would have died and medical aid would have been urgently needed. But because it hit the moon instead, basically nobody saw it except for a few thousand people who happened to be looking in the right direction. And this was the kind of perspective that really set me off on this journey to write this book, because it just made me think how much absurdity out there is happening that we just don't notice here on Earth because we are all here eating our cookies on the surface of our planet. Yeah, the night sky is an interesting concept because it's still there in the daytime. It's just kind of painted over with this veil of blue air. And so just to kind of get everyone in the mood of the concept of my book, I just want everyone to take like a yoga breath, 3 seconds in, 3 seconds out, because that's kind of what I like to do to just get the perspective in. 3, 2, 1. And here are some statistics about everything that just happened in those 6 seconds across the universe. So while we are here eating our cookies, everything is happening out there. It's kind of mind-boggling, and I don't think there's really any way to wrap anyone's head around it, really. But the goal of my book was to kind of give a glimmer of an ounce of a fraction of a mote of dust of comprehension, just to perhaps instill that sort of cosmic perspective that I don't believe me or anyone on this planet can really comprehend, but it's still awe-inspiring to just get a sense of it. And so this brings me to 3 fundamental questions that I really wanted to answer, or at least provoke some questions for in my book, which are, where are we in the universe? Where are we from in the universe? And lastly, where are we going? And the first thing that I wanted to look at was, where are we? And it's a very strange question to pose because in the scale of the universe, it just doesn't work. Because in the time that I've been giving this presentation so far, the Earth has already moved around 100,000 miles through space. We are moving at 600 kilometers every second, which means like when people ask me where I was born, I'm tempted to say Winnipeg, but a more accurate answer would be I was born in a desolate region in space that's now 800 billion kilometers away and will never be revisited by the Earth ever again. So where are we in the universe? That's always changing, but using a sort of metric to measure the absolute distances to everything, we can get a sense of where we are relative to everything else. And for that, we need the fastest thing in the universe, which is the speed of light. Nothing can break the speed of light. It is the ultimate speed limit of the cosmos. It's like a highway speed limit, except police officers have a much harder time pulling you over, and the fines are outrageous. But the moon, stars, everything is separated by great distances in space, and that takes time for light to travel that distance because light is really fast, but not instantly fast. Some of you guys on this webinar are on the other side of the planet, which means even despite Wi-Fi delays and slow reception, there is fundamentally a tiny lag in the time between when I say these words and when you see them, because it takes time for the light to wrap around the planet, bounce off those communication satellites, and make it to your computer. Of course, it's like a fraction of a second here on Earth, but for objects out there in the universe, the distances become so large that it's seconds, minutes, hours, even years, the delay between when something happens and when the light reaches you so you can see that it happened. And our solar system is huge. I mean, it took decades for our fastest spacecraft to leave it. It's just a few hours for a beam of light to travel from one end to the other. So that is just a speck compared to some of the bigger things out there, like our Milky Way galaxy. It's so big, it takes 100,000 years for a beam of light to travel from one end to the other. And this raises some interesting thought-provoking implications, which is humanity has only been around for a few 100,000 years, and human civilization has only been around for 12,000 years, which means all the light that we've ever emitted in human civilization is only big enough to fill this circle here in the diagram, with the rest of the galaxy fundamentally unaware of our existence because there has literally not been enough time in the entire history of human civilization for any of our light to reach them. This also has some nice solace in that we are going to die someday, but our light will keep emanating out there in the universe forever. So our images in some form or another will never go away, really. They will just get fainter and more dispersed. But our lights, as far as we know, light is forever. So light will just keep expanding. As we know, the Milky Way is not the biggest thing. It's just one galaxy out of several dozen in the local group of galaxies, which is just one group out of several dozen in the Laniakea supercluster of galaxies, which is just one of 10 million superclusters in the observable universe. And as many of you may know, the observable universe is everything we can ever see. And it is 46.5 billion light years in radius, which means a beam of light would take 46.5 billion years to get from here to the edge of the observable universe. But wait, that shouldn't make sense, right? Because the universe, since the Big Bang, is only 13.8 billion years old. Well, that's where the expansion of the universe comes in, because it's taken so long for light from 13.8 billion years to reach us that in the time that it's taken to reach us, the universe has almost tripled in size. And that brings me to the point where the observable universe, it's worth clarifying, is just an optical illusion. It's just a matter of the fact that it's taken so long for light from the edge of the universe to reach us that we can only see a certain distance, because beyond that point, there has literally not been enough time since the Big Bang for light to reach us. But there is still stuff beyond the edge of the observable universe, just nothing we can see. In fact, current theories predict the universe is actually infinite in size, and here we are limited to our tiny little bubble of light in the middle of an infinite cosmic abyss. In fact, when we look at galaxies at the edge of our observable universe, little do we know, but they can actually see their own other observable universe from their point of view, with them in the middle, which we cannot even hope to imagine because that is beyond our observable universe. So every point in the universe has its own observable universe that kind of restricts what it can see to that same sort of 46.5 billion light year wide sphere. So we are kind of cut off from what could well be an infinite number of stars and galaxies. And as for answering the question, where are we? I think this has only gone to further demolish any hint that we have any clue where we are in the universe. Which brings me to the next part. Where do we all come from? And this stems from a question that I asked a lot when I was little, and I'm sure most of you did too. It's, where do babies come from? And of course, if you take the innuendo and the scientific validity of the statement, babies come from the Big Bang. But of course, if we really extrapolate this back, this becomes less a question of where babies come from and more a question of where everyone comes from, and everything for that matter. If you take all the atoms in your body and you just dial back the clocks, I wanted to ask the question, where would you find those atoms, those particles at various points of the universe's history? And what I found was that just 7 years ago in the past, our bodies are recycling themselves so fast that just 7 years in the past, you did not contain a single atom that you are now made of. Because as we respirate and we breathe out and we eat and we excrete and we shed skin cells, our bodies are completely regenerating themselves atomically every 7 years. We are just retaining the same sort of physical form. But the atoms themselves are always moving out and about. And a few hundred years ago, your atoms were more or less evenly distributed around the Earth's crust, around the biosphere. So this packet of atoms that we call you is a very recent creation in the story of the universe. And if we go back throughout the history of life, your atoms have been part of several dozen organisms over the course of the Earth's history. And another really nifty coincidence that is well known is that there's around 10 to the power of 22 molecules in every breath you take, and around 10 to the power of 22 volumes of human breath in the atmosphere, which means when you average it out, every breath you take has around one breath. Every breath you take has around one atom from every breath that has ever been taken, which means every breath you take has one atom from Caesar's last breath, from Shakespeare's first breath upon performing Romeo and Juliet for the first time, from the breath of the first amphibian to ever crawl onto the surface of the Earth. And so, like, the atoms that are around us, they have a wild, wild history. And if we go all the way back to the beginning of this planet, Well, our solar system came from a cloud of gas and dust floating somewhere in the Milky Way that collapsed in on itself due to gravity and formed the sun at the center and the rest of the planets around the outside. Of course, the elements in this cloud kind of separated because the sun is mostly hydrogen and helium, and the Earth is mostly iron and silicon. But in a very real sense, the atoms in your body came from the same place and was probably mixed in pretty evenly with the atoms that are now part of the sun and Jupiter and Saturn and every other object in the solar system. And that cloud that formed the solar system, if we dial back the clocks even further, came from a star that was much bigger than the sun that ran out of fuel and exploded in a supernova explosion. Um, and the cool thing about supernova explosions is they are so powerful that they cook up heavy elements like iron and nickel and gold and silver and platinum. If you go all the way back to the Big Bang, you'd find that the only elements that the universe itself is capable of creating just from the Big Bang is hydrogen and helium. And when I look at myself, I am pretty sure I am more than just hydrogen and helium. And so when you think about how those other elements could have been created, there is really only one major possibility for where those were formed, which is at the core of a star blowing up. And so if you dial back the clocks far enough, every atom that is not hydrogen and helium in all our bodies, in all of this society, in our planets, came from the core of an exploding star some billions of years ago, and perhaps has been part of many stars over the history of the universe. And if you go all the way back to the very beginning, you can actually trace the structure of the entire universe down to just a few subatomic particles that appeared right after the universe began. So when the universe was small enough to hold in the palm of your hand, perhaps even smaller, when it was just a nanosecond old, this was just like this tiny compact ball of extreme unimaginable energy, and it was more or less completely smooth. Except there were a few tiny particle fluctuations, so little particles popping into existence all the time, basically. And when these particles appeared, they left little dents, little like fingerprints almost in this otherwise perfectly smooth baby universe. And these little fingerprints created hot spots and cool spots in what was otherwise completely neutral. And over time, as the universe expanded, those hot spots and cool spots went from the size of particles to the size of galaxies and even larger. And those hot spots and cool spots eventually became denser and more empty, and eventually led to all the structure of the galactic superclusters we see in our universe today. So, where do babies come from? You can really trace that question back to a couple subatomic particle fluctuations just a nanosecond after the Big Bang. And they do not teach that in sex ed when you ask where do babies come from. But has that for a big picture answer. And as for where we are going, we need to talk about cosmic doomsday. It's an interesting concept, doomsday. If you add up all the doomsdays in all the world's major religions combined, you get around 200 ends of the world that should have happened by now. But in the very real sense, our world is going to end in fire. When you quote Robert Frost, will the world end in fire or ice? Spoiler alert, it's fire. In around 5 billion years, the sun will expand and consume the Earth. But the universe itself is also scheduled for a cosmic doomsday. And the fate of the universe kind of depends on a battle between two cosmic forces, one of them trying to pull things together, which is gravity. You probably have felt it pulling you towards the center of the Earth every second of every day. And there's a second force, which is one that we don't know a whole lot about, which is called dark energy. And dark energy is pushing space apart. So it's kind of counteracting gravity's tendency to pull stuff together. And the question is, will gravity win and pull everything together? Will dark energy beat gravity and push everything apart? Or will the two forces just kind of chill out and exactly match each other? Well, there's three different possibilities. The first is maybe gravity does win, and maybe dark energy fails to push everything apart, in which case everything in the universe comes together and forms a nice warm hug, cataclysmically, as everything collapses into a black hole and is kind of gone forever. This is called the cosmic singularity, which is basically just a super duper mega black hole encompassing everything in the universe. There's this other theory that maybe as everything crashes together, instead of just collapsing into a black hole, it'll like bounce back into a new universe. And maybe that's how the Big Bang happened in the first place. Kind of like a phoenix being born from the ashes or something. But whatever happens, in this situation, we definitely die. So it's not very pleasant being cooked to 1 trillion degrees at the end of time. The second possibility is maybe dark energy wins and pushes everything apart faster and faster. And if dark energy wins against gravity, then everything that is bound together by gravity will stop being bound together by gravity. So in essence, that means our galaxy will come apart, and then the planets will spiral away from the sun, and then our Earth, which sadly is also held together by gravity, will kind of crumble like a dry cookie in all directions. And then those little pieces of the Earth will be ripped apart into molecules, into atoms, into particles. And at the very end of time, space becomes infinitely spread out in an instant. So dark energy spreads everything infinitely thin, and nothing ever happens again. In which case, for lack of better words, we also definitely die. And the third possibility is the least dramatic and gives us the most time to do stuff before the cosmos kind of kills us, you know? Um, Nothing dramatic happens with space. Space keeps getting bigger forever. It doesn't collapse, it doesn't rip itself apart. But if dark energy and gravity match each other, we kind of have an infinite amount of time ahead of us, which means, yes, things will get colder and darker, and galaxies will drift apart, and stars will burn out, and galaxies will just grow cold, and we will kind of just drift off into this cold, dark abyss, leaving an infinite amount of time for really strange things to happen, which I will get into just a moment. First, I'd like to say, yes, this kind of does kill us too, unfortunately, which is a very bleak sort of outlook, but I have some optimism for everything later. Before we reach this point, there's some really exciting things that could happen. Like I mentioned, in around 5 billion years, the sun will run out of fuel and will grow larger, destroying Mercury, Venus, and probably Earth too. We will have like 5 billion years to prepare for this, so we're fine. If you choose to stay, pack sunscreen. That's all I can say. Around 1 trillion times further into the future than this, it is hypothesized that protons, which are one of the most basic fundamental building blocks of everything in the universe, might have a half-life, which means they are unstable. And if you like your matter, which personally I do, then it is not in your best interest to have your protons falling apart. And this will be a very uncomfortable truth for anything that is still around in the universe to have to deal with, because in the style of Avengers Endgame, everything will kind of dissolve into subatomic particles and evaporate forever. And that won't be the end, actually, because there are still the objects, black holes, that will last around 1 trillion times longer. But even black holes, which are something that astronomers thought for many decades were immortal, tend to evaporate eventually as they trickle out a tiny amount of radiation called Hawking radiation. The largest black holes in the universe today are expected to last for around 10 to the power of 106 years, which is kind of an unfathomable amount of time. If you consider that to be the expiry date of the universe, 10 to the power of 106 years from now, that is basically 10 billion years from now. If you take that to be the expiry date of the universe, and then you think about all the stars in the cosmos and all the planets and all the life, well, the stars are what give warmth to planets and provide them with the resources they need to sustain life. If we lose the stars, then there's basically no place in the universe for life to prosper. And so when you think about the stars, which will last for 100 trillion years, then life really has a window of 100 trillion years in this universe to prosper. And when you think about the 10 to the power of 106 years that we got until the universe basically withers away forever with black holes disappearing, then this is the percent of the universe's lifespan that we have for life to prosper. So, hey everyone, this is the cosmic golden age. Never again will it look as good as it does right now. So, to me, this kind of underscores the need to just appreciate what we have right now, because in the big picture, all of this is going to be erased. And it's just really amazing to be able to experience it now while it still is in its full glory, while we still have a sky full of stars and galaxies we can see because they haven't all expanded away from us yet, that we have the energy from our sun to power the infrastructure to discover where we are in the universe in the first place is pretty amazing to me. And so I want to end on a note which is just why tell this story? Because this is basically the stuff my book covers. And if I had to summarize this, I would say we are living in very interesting times, to say the least. We are battling over geopolitical borders. We are disagreeing over very fundamental human truths. We are polluting the environment with greenhouse gases. And to top it off, we have 30,000 nuclear weapons, which we haven't really figured out what to do with yet. And so the point of this book, this cosmic perspective of sorts, is to frame everything, all the chaos that's happening on Earth, as something that is happening kind of like right there on a tiny blue speck that is drifting through a universe that probably has no clue in the heck that we exist. So to me, this perspective kind of underscores the need to just take a step back and consider what really matters on this planet. Because when you see people not for a nation or a race or a religion, but for a collection of atoms, just a bunch of particles, then how different are we really? Because you can create 99% of everything in the universe with just 5 different elements. And yes, there are 118 elements that we know of, but with just 5 of them, you can build most of the universe, including us. And so to me, it's a different sort of way of seeing the world because there is so much cosmic wonder around us all the time. I want to just kind of end by saying, stay curious, everyone, because there's so much amazing things to be discovered, and as long as we keep looking up, I think it really signifies that we haven't got it all figured out yet, and that's really exciting. And if you've checked the news lately, we sure as heck have not got it all figured out. So yeah, stay curious, everyone,
Sure.
and I want to just end by saying it's kind of not right to be calling this the end when we have so much more ahead of us. By the way, my favorite TV channel I just discovered is no TV channel. Because when you detune a TV, you set it to static, which basically picks up on some of the cosmic microwave background radiation. And this has become my favorite track to listen to. It's just like, but it's so cool because it's the radiation left over from the birth of the universe itself. And I'm like, this really was the first music album ever broadcast. This is like the #1 Spotify hit for anyone listening to music 12 minutes after the Big Bang. So yeah, go give it a listen if you can. It's great. Yeah, so for anyone who wants to, I don't want to like leverage this into like a sort of capitalistic trade show, but I'm going to for just a moment by saying, if you want to buy my book, this is where you can get it, and I would be honored if you wanted to give it a read. I am so honored to have been invited to this Global Star Party, and yeah, thank you so much for having me on.
Thank you, Nathan.
I hope you sleep well tonight.
So, so actually, Scott, I want to ask a couple of questions to our
Okay, all
very
right.
young. So when I was young in the 70s and TV used to go off and it just went, what you're saying was TV never really went off. I was just watching the Cosmic Microwave Background Channel. Is that true?
I mean, it's not all the
Some
radiation.
percentage
Like
of it. Yeah.
there is a good portion of it is cosmic microwave background radiation. But yeah, TVs are just tuned to pick up on radiation. What turned off is the radiation supplied on a frequency that is designed to be a human TV channel is what turned off.
Right. Well, it gives a
But
little different perspective because seeing back in those days, TV could go off. You flipped off the switch and you did something else to go to sleep. But thinking back, that basically makes me say, well, TV never really went off. It's just were you interested in what was actually being shown, which was coming from a more distant source than the in the older days with the signals being sent over antenna and now signals being sent every other possible way, including Starlink. So that was so deep that's made me forget my second question. So you know what, no, I really enjoy your presentation and I enjoy your perspective, which is quite remarkable considering what we those of us who are in our 50s are kind of right in the middle of either caring about science or caring about who's about to win Stanley Cup, and there's rarely little in between. So I for one appreciate your view, and it reminds me of my second question. It just came back to me. Will there be an audiobook version of your book?
I would have to check with my publisher, but I would love to create one. So
Okay, well, if
probably.
you do, I would definitely love to see it. All right, Scott, I've taken enough
Okay.
time. Back to
All
you,
right.
Nathan.
Although I
Thank
have to
you again.
say, one or two of the characters in the book, I could see Adrian taking some helium balloons and voicing those.
You feel free to bring me in. I'll do whatever impersonations I can.
I
Well,
would be honored.
Nathan, thank you for bringing all your energy and enthusiasm to Global Star Party and sharing your latest creation with us. And expect to see many more such things as time goes on. So, fantastic effort, and thank you for presenting it here on Global Star Party.
Thank you so much for having me, and congratulations again on 150. That's
Thank
awesome.
you. Thank you. Well, all of you make it happen, so that's great. Okay, Dr. Levy, our next speaker is David Eicher, and so let's bring on David. David and David. It's the David and David show, and um, uh, so I'm very happy to have David Eicher on, especially after all of his effort at Starmus, and so and I think you've come to kind of share some of that experience with us, and those of us that have had a little taste of it, it's fantastic. But you've been going to Starmus since the early days, is that right?
Almost since the beginning. I had a conflict for the first Starmus, but I went to the second one and gave a talk, and foolishly they put me on the board with them, and I've been very involved with it ever since. So about a decade now with the Starmus group, and we had another one. And I think even though we're really just a recombination of atoms from the early universe and from the deaths of stars or the collisions of neutron stars, as Nathan mentioned, I think it's important for us to get enough sleep as human beings. One of the things we discovered with this Starmus in Bratislava is it's kind of hard to go on 4 hours of sleep every night.
Oh,
So
yeah.
we survived Starmus, and it was incredible. I'll tell you a little bit about it. But I'm glad that Starmus doesn't happen every month. It would kill us.
Yep. It is, just doing one and seeing how much effort was going on almost round the clock, was really amazing. So I think I told you that I thought that Starmus was like the Woodstock of the astronomy world. So, but it's probably more than that. Probably Woodstock was an easier event to put on.
Well, I don't know. And I didn't make it to Woodstock. I was just a kid, and I think they had more people than we did at Starmus, but it was a really
Maybe.
good event. It was in Bratislava this time, Slovakia, another really lovely European city of about 500,000 people there, as we were in Armenia a couple of years prior. And we had some really great talks and some good times, which I'll describe here shortly.
Sure. Okay. Well, it's all yours. Thank you, David.
Thank you, Scott. Thanks for having me back on, and I will share my screen, and I will try to share the correct screen. Uh-oh, now it's saying, oh dear God, I may have a problem here, because it's not allowing me to share, I think. Let me see if this works. Uh-oh. I don't know why, Scott, it's not allowing me to share the right screen here.
Hmm.
Um, hmm. This is not good.
You have a two-screen system going there?
I do at the moment here, yeah. No, it's not happy. Let me see if maybe I can come back in a little while after another speaker and try to
Okay,
debug this, if that's
okay, we
okay.
can do that.
And forgive me. This is,
Sure, no
I'm
problem.
at work, which I never am at work, but there's something going on at the house. So let me take a shot at making this work
Okay,
next in line, and forgive me.
okay, no problem, no
Okay.
problem. It's just the first time, I think, for you. So now, compared to all of my mistakes, you're virtually perfect. So
I don't know about that, but thank you, and I'll try to figure out what's happening here.
thanks.
David, I'm just gonna blame the computer because you've successfully done this so many times. It has to be the work computer.
You know,
That's
I'd
right.
like to
Somebody
say it
sabotaged
because
him.
it was because I wasn't getting enough sleep recently. That would play right into
Yeah.
the talk, but I'm not sure what's happening here. And our company, we were just sold to another company, and now I've got multiple email windows open,
Oh
so
no.
this could be problematic. But let me try to fix this and come back in a little
Okay,
bit here,
okay.
Scott.
All right.
All right, so Lori, if you're listening, Lori Ansorge and Don Nab can come on, and we will have Dawn introduce Lori. It's her first time to be on, but I did have the good fortune to meet Lori a couple of times before, so. But Dawn, go ahead.
Okay, can you hear me and see me okay?
Yeah, it's perfect.
Yes.
All right, so this is the Astronomical League section. So Lori's going to join our rotation with myself and some of the officers of the league. We aren't officers. I'm chair of the Mideast region. Lori is treasurer for Westminster Astro in Maryland. But I met Lori last summer at, well, here it's Green Bank Star Quest 18. We had our Mideast region of the Astronomical League annual meeting, and Lori participated. And within a few weeks later, she had created a more user-friendly Facebook page for the Mideast region, which we refer to as Merrill, Mideast Region Astronomical League, Merrill. So I've gotten to know her through that. She is a stargazer for her entire life. All right, she's a life member of the Astronomical League and of Girl Scouts USA. So she does a lot of work with the Girl Scouts. She is a NASA partner with Girl Scout Stars, Eclipse Ambassadors, and Eclipse Stars. In fact, earlier I heard mention of Astronomy Day. Well, Lori led a team of Girl Scouts that won the 2019 Astronomy Day Award from the Astronomical League. So she spends a lot of time doing outreach. In fact, she has reached the Master Outreach Award level in the Astronomical League. What's that mean? I mean, she spent a lot of time under the stars with the public, trying to share the wonders of the night sky with them. So that's really what the league is about, is sharing the night sky with the public. So yeah, she's the treasurer of Westminster. She's also a member of Tri-State Astronomers. Being treasurer, she's the Astronomical League coordinator for that club. She was the #1 recipient of a new observing program in the Astronomical League, and that is the Messier imaging. She was #1 recipient, and when we see Scott back on the screen, you'll see behind his shoulder is a unistellar automated telescope, and that's what Lori used to get this award. So congratulations to her. She lives in Maryland, her spouse Al. And she says 3 spoiled rescue kitties. Okay, so they do a lot of outreach events. She's a gardener, a quilter, and a citizen scientist. So I'm happy to welcome Lori to the Astronomical League GSP team.
Okay, great. Let me find her. There's
There she
Lori.
is.
I see her now. Here we go. Lori, thank you. Thank you for coming on to Global Star Party.
Thank you. And in keeping with your ever-changing cosmos theme, what could be ever more changing from our small little blue speck egos than to look up and have an eclipse? So what I'm going to bring to you tonight is my experience as an eclipse ambassador. The Astronomical Society of the Pacific has been a wonderful resource for a lot of amateur astronomers through the years, and others just interested in the night sky. And they provided the resources and the training for the Eclipse Ambassador experience. So the goal for the program was to find people off the beaten path and make them aware of these eclipses. And let me put this on here. And also to make sure that they were aware. And to do that, they paired us up, amateur astronomers, with undergrad students. And they were also a little concerned about the graying of the astronomical clubs throughout the country and felt that this would be a way to kind of bring some youthful vigor to it, I suppose. So I was paired up with Shannon Markward, who just graduated from Towson University, and she will be in the fall going to UMBC to pursue her PhD. So they paired us up. They gave us lots of training. And what you see here are a couple of the slides that we used for some of that training as well. So the Eclipse ambassadors are from all over the place: Alaska, Hawaii, Puerto Rico. And what this map is showing is where they hail from. And of course, many of them went to the path of totality, and we'll cover that in a minute too. What was really important was that each pair meet a goal of a minimum of engaging 200 people. And with all of the outreach that our club does, which is usually in the top 5 in the country on Night Sky Network, which is also managed by the ASP, it didn't seem like it was going to be that hard, but I knew that my undergrad partner would certainly have an experience when it came to outreach, which was another goal of the program too. So we had to engage 200 people minimum and make sure that at least half of them were from underserved communities. And the reporting wasn't real rigorous, but I like my statistics, so I made sure. We actually engaged over 800, and we had, by my estimation, about 39% of them were from underserved communities. The ASP as a whole exceeded their goals. They had over 100,000 people reached through all of the Eclipse ambassadors. And here you see some pictures. You have some Girl Scouts being engaged with the yardstick scale model, but that Shannon's guiding them through. And then at Soldier's Delight Nature Center, we have the public engaged in the same thing. Here we have a club member in the lower corner that's using light and to scale models of the Earth and Moon to explain what happens with an eclipse to some Girl Scouts. So part of what we created awareness on was where these eclipses were going to happen and what percentage of an eclipse people would see and what kinds of eclipses there would be. For example, the annular eclipse, that comes from the Latin term ring, and thus we call it the Ring of Fire. And the Explore Scientific folks, they sponsored an expedition that was actually at that Texas intersection between the October eclipse, the annular eclipse, and the April eclipse. So that was pretty exciting that was going on. We also had cup models where we could demonstrate for the public why it is that if you have eclipses only happening during a full moon, but you have a full moon every month, actually 13 of them in a year, why it is you don't have a solar eclipse every month. And the answer to that through this hands-on demo was that when we look out into the universe from planet Earth at our solar disk plane, the moon is actually off of kilter in its orbit around us by about 5 degrees. And so it takes a season, which is usually spring and fall-ish, within a month each way, for these nodes to line up enough that you have this pattern of the sun, earth, and moon coming together for that shadow. So this is a complex concept to explain to the public, and yet we were having kids of all ages be able to demonstrate that directly, which was neat. So in our many road shows, we were at the library, and they have a nice new AV center there, and we did the science fair at Montgomery College, which attracts thousands of people. So actually, through the different events that we had, we actually interacted with many thousands of people, but ASP doesn't like to double count, so we didn't. And in the lower right-hand corner, we did an encampment with the Girl Scouts in Central Maryland. And here they're looking at a video screen under some shade, of course, of what the telescope in that upper right-hand corner with the proper filtration is looking at. So they can see it a little bit bigger and get a little more sense of that detail. So we approached it from many different angles. We also, and here's a close-up of that, that eclipse in the cup model. You can see that the blue line is that looking out into the solar disk, and that red line represents the lunar orbit. The pin in the side just keeps the cups tilted at that 5-degree angle. And then that little pom-pom white dot is the moon. And it's one of my favorite words that when these things line up and create that shadow, and that's syzygy. Look, Mom, no vowels. So syzygy is one of my favorite words there. And we hit it from a couple different angles too, no pun intended. We showed the version in the upper right-hand corner here where you have the lunar orbit off kilter, but the lunar nodes on the top and bottom of that graphic in the upper right-hand corner show that when you're near the equinoxes, that season on Earth because of the tilt of the Earth, that's when those lines of those orbits line up in a way that you get that eclipse possibility. And then, of course, in the lower right-hand corner, it shows also that the moon could be too high or too low for winter or summer, and thus that shadow that would have been a nice eclipse goes off into space, and no one on Earth appreciates that. We also set up our program so that we were able to do it indoors, outdoors, nighttime, daytime, rainy time, didn't much matter. And because we were having many large groups that we needed to cater to, we ended up being resourceful. And I had some leftover plastic corrugated black board and cut that up to create a bunch of yardsticks and marked them. And that's what the girls are all holding in these pictures here, so that the Earth-Moon scale model could be demonstrated. And in fact, in this particular model, the Earth is 1 inch and the moon is 1/4 inch. And the question we generally asked was, using this scale, what is the distance between Earth and moon? And the answer is 30 inches, because it's 30 Earth diameters. And that's a concept that people don't get because your textbooks, because the pages are only so wide, they show the moon and the Earth close together. So I think in all the time that we were doing this, I had 2 people with the correct answer to that. And along the way, we were interested also in ensuring that people were prepared and safely prepared. So since most of our outreach was in Maryland, we did show what the possibility of clouds were. And we had people all geared up for, if you want to see it, you go to the southwest of the United States. And that way you can avoid clouds versus the northeast. And as we all know, for April, the opposite happened. But just like your investments, past performance does not indicate your future returns. We also made sure that people of all ages were well informed to not use those solar filters that go onto eyepieces. And I still carry mine around that came with my first telescope as a demo. You see this, politely inform people that you've been advised by your local Eclipse ambassadors that this will hurt you. I met Saturday night at one of our outreaches a high school astronomy teacher who was actually a biology major, and he volunteered because they needed an astronomy instructor. And as he was using the telescope on the sun and doing things he shouldn't, he also used his eclipse glasses on the eyepiece and watched it burn a hole pretty quickly. Luckily, his eye wasn't there.
Oh my God.
Yes, but at the same time, too, I found a map that showed the past performance of April tornadoes from 1950 to 2018. And as you can see in the lower right-hand corner, there's a lot of red dots there. So had people be mindful of that. So we did all that briefing, and then we headed to Leakey, Texas in the Explore Scientific Expedition. And with my unistellar telescope, I got this nice set of images. The lower left-hand corner was with my DSLR that was set up with a 400 millimeter lens. And of course, I had to do a lot of cropping to get that one. I was thrilled. I'd never seen a total annular eclipse. Did it get dark? It looked like it was overcast. It didn't get real dark, and that's okay. And then in the interest of time, just a quick couple of images blended here in a video to show you what that looked like in a somewhat of a time lapse. Fast forward to April, because after briefing all these folks about the eclipses, we wanted to go see a total eclipse. And you would think with all these clouds forecast that it wouldn't be much of an event. And in fact, if the clouds hadn't parted, it would have been still an event, because you can see from the upper left-hand corner going to the right middle that it started to look like a sunset, and then it got darker, and it was dark enough you really couldn't see, just like nighttime, total darkness. And in fact, I made a point of not having the camera on automatic so that I could capture a sense of what it felt like to be out there. And that was quite something. And it was quite something listening to the crowd as well, as we all were rejoicing and seeing this total eclipse, safely, of course. Put together a little montage. This is again with my Unistellar EV2 scope. I had my husband running an Odyssey Pro as well. I didn't include any of those images here, but even though we had 4 minutes and 26 seconds of totality and maybe saw 20 or 30 seconds in between clouds, a quick finger, I was able to capture these very unique images. Nobody else in the world has these exact images, because nobody else has the clouds exactly like I have them for this eclipse. And here's a little video treat for you too of what that looked like. The big knock my socks off moment was in looking at the images, not realizing that my EV scope was going to give me these prominences on the sun in totality. Forget the clouds. I had no idea that my little computer scope was capable of this. And I am just thrilled to pieces and thrilled that it was able to track so well. So that said, let me just say it takes a village. It takes a big village of a lot of organizations to help make this happen. And then as I am, as Don said, representing the Astronomical League, I have to mention that we have Alcon coming, to Alcon 2024, July 17th through 20th in Kansas City. And let me tell you from firsthand experience, it's a great way to meet new lifelong friends. I still talk to the people regularly that I met at our first one. It's a great way to get inspired. You can visit fantastic astronomical sites, no matter what city they hold it in. You're always learning new things, and you get to be with your people. And I threw the link up here too, but if you go to astroleague.org. You're going to find it pretty much. And from the Westminster Astronomical Society and our 40th anniversary year to the Kansas City Society and their 100th year, we just say congratulations. And then next, for the Astronomical League Live, which is thanks to Scott and Explore Scientific helping them with that. The next event is June 14th at 7 p.m., where Dean Regis will share his adventures as the astronomer in residence at Grand Canyon National Park with his presentation, Stargazing and Hiking in the National Parks. That's something I'm really interested in as well. And I'll just take a moment to ask if there are any questions.
They are happy that you're here, but I don't see any questions, Lori.
Okay.
You must have covered it.
All right. Very
That's
good.
great. That's great. Okay, so Lori, thank you very much. It was, I have to say, it was a great pleasure for David Levy and myself to have you at the Eclipse expedition. And, you know, I could tell at the event that you'd gotten some really fantastic images. You gave me a little peek while I was out there, so that was really cool. You know, will you also be at Elcon? Are you heading that way? Okay.
I am.
Right.
And our
Okay.
club is going to be picking up some awards, so I'll be there as the representative
Oh,
as
yeah.
well.
Well, all of the rest of you that are thinking about going to Alcon, make sure you take some time to meet with Lori. So you'll be glad you did. Thank you so much.
Thank you.
Yeah, thank you. And thank you, Don.
Look forward to seeing you there.
Okay. All right. So up next is Dr. Frank Marchus. If you have not seen him give talks on Global Star Party before, I can do a little bit of an introduction. He is one of the astronomers at SETI, and that's the Search for Extraterrestrial Intelligence. He is a very active outreach individual. He runs citizen science. He is on lots of science papers, and he's helping other people learn the way to incorporate science into their lives as one of the people that developed and created the unistellar telescope that Lori was just talking about. I know that they worked very hard to make the telescope also track the sun during totality, which was not an easy thing, you know.
Yeah.
I'm happy too, Frank, that you got to experience Starmus. You are the Energizer Bunny of astronomy. You've been all over the world. You were in the islands. Was it the Maldives? Is that where?
Mhm.
Okay.
Yes.
You went from there to doing, you know, a major outreach event there, and then you flew out to Europe, to Slovakia, and now you're back here. So thank you for coming on to Global Star Party and making this presentation.
Thank you. Yeah, thank you for having me. I think the topic is great. We're going to talk about what changed in space, and what I want to talk about specifically is how we can use the unistellar telescope for this. So hopefully you see my screen, right?
Yes.
Yeah. All right. So in astronomy, we call events that appear and disappear in the sky transients. It's a word that I can barely say because I have a French accent, but so we decided to call that cosmic cataclysms because most of them are in fact related to destruction or to energetic activity in the sky. This is the work which is led by Tom Esposito, the space principal in my team, my number one, and two other scientists, Lawrence Gros and Amaury Perrochon. But as well, I should thank all the citizen astronomers and the Unistellar team who contributed to this research, funded by the Lonsberry Foundation. So the goal of the SETI Unistellar Network for Cosmic Cataclysms is to provide the fastest ground-based photometric follow-up of bright optical transients. Meaning, in short, that if something happens in the sky, the goal is that in 2 minutes, you get a notification on your phone somehow, and you can observe it. We are not that yet, but we are not yet there, but we are very close. So we do right now routine observation by photometry, meaning analysis of the brightness of the light of transients. We have short campaigns and also high cadence campaign. And we anticipating the arrival of the Vera Rubin. I believe that in next year, we will see a radical change in the way we do astronomy because of this facility that will provide millions of alerts every month of things happening in the sky. So we are going to see the change in astronomy, and our telescopes, our network of telescopes will be part of that. So just to give you an idea, we started this project in June 2022 in the beta testing. It's one of the last citizen science projects implemented in a telescope. As you know, the unistellar telescope software evolved over time. We mentioned that we have the Eclipse for guiding just before the Eclipse. So we had some citizen science as well as we get new projects and new collaborations. We now can do full alerts and data processing since February 2023. And we have a partnership with Colibri to send notification through the app. And finally, we recently implemented in March of this year the gamma ray burst alerts from SWIFT, the space telescope. I'm going to skip this because I have the feeling that everybody knows what is a unistellar telescope. I just would like to mention that now we have a new model called the Odyssey, which is smaller, more compact, and it can still do the science that we have prepared for the Eviscope 1 and Eviscope 2, meaning that if you get an EDC, you can still do citizen science. The philosophy of Unistellar is to bring the people for the images and make them stay and observe for the science, basically. The idea is that, yes, you get great picture observations with your telescope, but when we want to start using more and more your telescope, we give you a meaningful activity, and the scientific investigation is one of them. We don't do that by ourselves. We do that with partnership with a lot of institutions around the world. AAVSO is one of them, NASA as well, and the Charles University or the Observatory de Paris in Europe. So if you join the Unistellar network, you're gonna be joining an array of a network of 13,000. I should have changed this number, and more telescopes. It's growing still, and we have more than 500 people who basically participated to the citizen science campaign. We have now 2,500 people in our Slack workspace, which is the way we communicate with our citizen scientists. And this animation shows the progression of the network. I hope to have a map for 2024 pretty soon. Okay, so how does that work? Well, you get all the information about our citizen science on our website, on Slack, or on the Astrocolibri app. Okay, you don't need to be to have a unistellar telescope to be able to see our alerts. We do the alerts for everybody, not only for unistellar. You basically can one click tell the telescope you want to do this observation, and the telescope will basically suit to the right location and start taking data, what we call a deep link. You upload the data, and a few hours later, now it's less than 24 hours in the best case scenario, you get basically the data process and a report showing basically your observation, stack image in this case, and the measurement of the photometry. So this is an observation from Sophie Saibi, and you can see the light curve of supernova, for instance. At the last point, the yellow point, is her observation. The previous one was taken previously by other citizen scientists. So we got our alert through various surveys. We use mostly the the ZTF survey at the moment, which is analyzed continuously by AlertC. AlertC is an automatic learning system. It's based on machine learning that sends alert and notification when something happens in the sky, and it does use the Palomar survey, the ZTF survey for this. We recently as well partner with SWIFT, the telescope, so we also have gamma ray burst alert from this telescope. We filter all these alerts to make sure that they're observable with the EV scope. So that's to mean they're bright enough, typically magnitude less than 16.8. For those who don't know, we published recently a paper showing that we can reach magnitude 17.2 in 5 minutes with our EV scope. So 16.8 provide a good sensitivity, a good quality, photometric quality. That's the reason we put this limit for our telescope. I'm going to go through the detail maybe if you have more questions, but we target, basically we send a coordinate through this deep link here in our website. You click on the deep link and you open basically the application of the telescope and you can start your science. So the goal, as I mentioned, is that from the time that observation is detected by AlertC, we would like it to be basically in our database in 2 minutes. And we are very close to this. To be honest, now we're probably at 4 or 5 minutes for most of the alerts. So if you're observing, you will get an alert on your phone and your supernova appearing here. You click and you observe the supernova. So what we've done, a few examples is the observation of the supernova 2023 IXF, which was the closest supernova for the past decade. So this is the light curve on the left from our data. So something interesting, the red line here, it's basically the time of the discovery of the supernova. And as you probably know, we also ask our citizen astronomer to send us their observation if they observed previously. So we went through the database, and from this observation, we basically detected the supernova before the detection by the Japanese astronomer, and we also nailed down to an accuracy of 1 hour when the supernova ignited. And this is an agreement with a scientific paper that was published almost at the same time. On the right here, you have a color, the brightness of the supernova over time with all the citizen astronomers that observe it. Another target we are observing at the moment is the nova TCRB. Everybody is observing it, I know that. And the goal is, of course, to be the first team to detect the ignition of the supernova. These are the observations we have collected recently. You probably know it's a supernova that was that was bright in 80 years ago. It's a binary system, so predictions modelization implies that it will ignite again by Schaffer in 2023 in this year between April and September. So we are observing, our citizen astronomer observing it every night. We on average 3 observations per night. We have already collected 490 observations since July of last year. Something new we implemented this last week is a triggering system that analyzes the data collecting by the telescopes and as soon detect the ignition, we'll send an alert to all our network telling them, observe TCRB, it's on, it's happening right now. So let's see how it works. We have been testing this on different cases, so we hope it will allow us to basically get a clear light curve of the ignition of the supernova, so we better understand the type of physical process we have in this binary system. So I'm going to end here because I would like to take some questions by saying that we are now, yes, having a real-time alert system for ZTF and SWIFT, as I mentioned, with a time difference of 2 minutes. You don't need to be a Unistellar user to have access to those alerts. They're on our website, on Astrocolibri and Slack. You can see the website, the web page here. We're still working on making the web page better and more accessible, of course. This is a work in progress, and we hope to hear more about your comments if you look at it. We have observed 1,700 transient observation in 2023 from 200 citizen scientists. So there is a strong interest for this type of scientific studies with our telescope, and we're very glad to see that, because this was funded by a foundation at the time, and we have really no idea if our user will be interested in this kind of work. And I just would like to say that we are working now on implementing more alerts from different sources, such as gravitational waves, neutrino, and maybe laser SETIs, the search for laser pulse in the universe. And that's all for me. Thank you.
Okay, great. So there is a question, and let's. This is from John Ray. Frank, he's asking, how much of the sky at any given location do you feel is necessary to participate? He says that, this is regarding those of us with limited access to open sky.
There is so many transients that you will be always find one in the 20 by 20 degrees sky. So you, if you look at our list so far, we have the recent transient. There is something like 15 detecting over the past months, and that can still be observed with our telescope, meaning they're bright enough. So even if you have a small patch of the sky available, you will find a transient that will be observable during this night. You just maybe have to wait, but you will be there will be at least one, because they're everywhere. That's the beauty of transients. They're not in the ecliptic; they're really everywhere, because they can be any type of system of stars that can become a transient.
Fantastic. There's Senthil Nagapan, who's going to be, his son is coming on to this Global Star Party later in this program. He is curious how to enroll into your citizen science program. He has a Unistellar. And he just wants to know what steps he needs to take to enroll.
So we're gonna make it simpler, but at the moment, what you need to do is to start the app. Okay. And then you go to the science mode, and there is join the citizen astronomer community. You click on that, you fill up a form. Hopefully it's gonna show up if you see my screen. And we're gonna send you a Slack invitation, and you set. That
seems pretty easy to me.
Yeah, you just need to be curious and go to this app and click on this. It's not clear, it's a button, in fact. That's something we're gonna change. And you learn with other people. I mean, you will see that there is every month we have typically 30, 50 new people coming. So at the beginning we train them, and then the citizen astronomers who have been there for a long period of time, they generally help the newcomers. So it's a work that they do together, and they decide to observe a comet, which is kind of easier at the beginning, and then they go in complexity. Transients could be considered the most complex object to observe because as I mentioned, they can be anywhere in the sky. But yeah, it's not that difficult. The point is to go to the Slack and to engage with the community to learn together. That's really my main recommendation.
Okay. All right, and Lori, who just gave a presentation, says she loves her Unistellar, and she enjoys that she serves as one of the beta testers as well. So,
thank you very much. We always need beta tester. There is always something wrong, right?
Oh yeah, that's true. Well, when you have good beta testers, you just make the product better and better. So
yes,
that's great stuff. Okay, so let's go to our next speaker,
thank you.
which is Adrian Bradley. Frank, thank you so much. Thank you.
Thank you very much.
Okay, yep. All right, Adrian has been on Global Star Party many times, and he inspires us all the time, I think. Certainly inspires me with his incredible landscape work and his night sky photography. And it's been fun to watch Adrian learn more and more about the stars and the deep sky objects and the community and all the rest of it. So I think it's fantastic. You belong to a couple of astronomy clubs right now, including
Yes.
the Royal Astronomical Society of Canada, although you're a Michigan native, I guess.
Yes.
And
You,
so
yeah, I'll
you're
give the
you're a
rest of them.
you're a citizen of the world, as far as I can tell.
Yep. And other astronomy clubs, the Warren Astronomical Society, I need to mention them a little more here. The club that I typically mentioned, University Lowbrow Astronomers. I'm a member of both of those clubs.
Uh-huh.
In addition to the RASC, which I joined, and a member of the Astronomical League. So I think in the theme of ever-changing cosmos, I can certainly say that over the past few months, um, my cosmos has changed a lot. And this particular change in where my work is visible was a very important one for me because David Eicher, who was here, we started the process a year ago to say, talk about your journey into doing nightscapes. And many of you that read Astronomy Magazine have now seen my my opening story, of which I hope to continue writing articles, from someone who takes his camera, goes out and captures what he can, what he can capture, and just demonstrating a love of our cosmos and trying to share it to a bunch of different people. One of the challenges I have is, in my cosmos, there are many people that have many problems, day-to-day problems. We saw the presentation about all the things going on in politics and all the things
Oh,
happening,
yeah.
all over the world. And, really it was he redescribed the pale blue dot Carl Sagan
Yes,
sort
he
of,
did. I
would
don't even think
take
it
a
was a
look,
dot anymore. It was just like a tiny dot
yeah,
on a dot on a
a dot
tiny
within
a dot
within
within a
a
dot.
sunbeam. And yeah, and regardless of how you feel spiritually, or those of us who are in a religion, or those of us who are the exact opposite of that, what ties us all together are the atoms in our bodies and the universe that we live in. So with that in mind, I went from trying to do images to gain attention, and I decided to use images to describe what I'm seeing, and describe what it is that I'm looking at. So in other words, the purpose of the images is to take you with me. I'm not looking to just create pretty pictures so much as, here's a slice of life on our planet, and here's what it looks like when you add the night sky to it. So let me go ahead and go through this. Scott, I will share just a number of images. Some may look great, some may not. That's a part of the journey. Like, this composite didn't go so well, but this was a few months ago when this part of Cygnus was setting in the west. So let's roll through here. Same part of Cygnus. And one of the things I'm going to discuss, I'm going to be taking a lot of my images that feature a lot of light pollution and show the difference in what you can see in the night sky, and why it may be harder to do the sort of outreach that I like to do in skies like this. Well, they can see the moon sitting on the horizon, but all of this with the North American Nebula and everything, hardly any of that's visible here, just because of the giant towns over Lake Erie. This is in Canada, and so we're seeing a lot of the influence of the larger cities. This is, I call it Cleveland versus Sirius. And you've got this giant dome, which is the city of Cleveland, which was in the path of totality. That'll come later. But you have Sirius competing, um, being just bright enough to shine through this light dome when you take an image. You've got a little bit of Milky Way, which of course 30,000 light years away, but does not shine as bright when you get to our planet as a major city. And so that's the part of what I want to write about and bring images in for, are to discuss these differences and what we can see and the various forms of light pollution. Some of them, a lot of them, when we think light pollution, we think man-made, but there are other forms that the cosmos brings out to us that could be considered light pollution, but we typically don't look at it that way. And you'll see why as I get to those images. So you're seeing, the Orion was rising at this time and Cygnus was setting. And so these various views, many of you have seen before in Global Star Party, but you see from long exposures to get all of this hydrogen alpha data and, try and get doing composites. So your sky sort of explodes over here to a very simple, this is what you would look up and see with your own eyes. Cygnus Cygnus area isn't as well defined, but it's there. And so the winter months hit and you take a few shots. Now, as far as the most light polluted area, I'm still getting notes of the Milky Way here, the Perseus region and Cassiopeia above it, over some farmland, and there's a few bright towns near where I'm from that are casting the light. This is a difficult place. I still took the picture because of this oak tree over here, but this is what, even in a country area, people contend with. They're seeing stars, they're seeing constellations, but without the help of EV scopes and things like that, there isn't much outreach you can do, because the skies just aren't as dark. And in our dark sky parks, here you have a long exposure showing some of the objects you can see in the night sky when Orion stands up. And of course, the seasons are a method of change, and our landscape images can show the differences in how our sky moves and where things move in our sky. We don't worry so much about satellites, as we've got all sorts of things that'll come across an image, such as planes and sometimes meteors will go through. Now, you see a lot of course, more light pollution here. This is what the scene looks like to the naked eye. You can barely make out the winter Milky Way. It's stacked. So some of this, some of the HA emission we're still getting, but we stack this scene so this is a more natural representation. This glow is the glow that you would see in if you were standing right where I was. And this is a dark sky park. Of course, 10 years ago would have been darker. So with the winds of change, you've got this cottage where my priest once lived. And at the time, I decided to take some final pictures of the cottage. And so after this, and this failed attempt to get this satellite, continuing to work on compositions with trees because it's very difficult. And every once in a while, the moon, Robert Reeves will be coming along, and there will be some even better pictures than this. Every once in a while, I get a pretty good, sharp enough picture to where you can see features and details on the moon. For those of you taking moon pictures, the sharper some of these features in this mare show up, the sharper your pictures. I take pictures with a 600 millimeter lens and a Sony A7R4. I've handheld these shots and the pictures come out. So we'll get to, so this isn't the first time that I've taken an Earthshine moon. And of course, Jupiter showed up in this picture. This is with a tripod. That's Jupiter and 4 Galilean moons. So maybe not the coolest picture you'll see, but sometimes I take pictures just to see if I can capture certain things. That'll come up later. What I'm able to capture using photography equipment that most would use to capture the birds. So there's a lot more that you can capture, and they don't all have to be perfect images, but they can be very nice keepsakes and reminders. So as we move along into 2024 and we're taking pictures of the sun, why? Because there's an eclipse coming. So here's the area that I've chosen to film the eclipse from. Here's pictures, test pictures that I took. Here are the clouds that came over and threatened to make the eclipse harder to view in Perrysburg, Ohio, first contact. And you've got that sunspot grouping there. Then various views of the moon invading the sun's space. This one somehow went back in time. And then if you didn't live on the center line, you contented yourself with seeing a sliver of the sun left and the weird color in the sky, but then the moon moved off of the sun and your eclipse was done. But for those of us who went to totality, we had an opportunity to see the eclipse. We took pictures. Prominences were very visible. With the high cloud cover, I didn't get much else of the corona. There were some amazing and beautiful longer exposed shots, bracketed shots for the corona. I just aimed my camera without a filter up at the moon and took a shot. But I did get for the first time Bailey's beads, which you're seeing here. And it's a very active side of the sun here that we were able to see. And then this picture, which if you're seeing this, you should probably look away as fast as you can because the eclipse is about to end. So there were a couple more pictures that I took. Now the way that the eclipse, I actually have this backwards because the way that our eclipse started was with the moon coming in and causing the diamond ring to show up here, whereas the end of the eclipse, the diamond ring shows up here. If you're in direct line, your diamond ring starts, in the center of totality, your diamond ring starts on one side and ends on the opposite side. So those of you that got a chance to see the longer totality saw your diamond rings go from one end to the opposite end. But those of us that didn't saw a diamond ring in one part and another diamond ring elsewhere. And then, of course, totality. There is a lot of detail in this corona that some astrophotographers, many, in fact, was able to get. So, and here we've got a lot of artifacts. This is not, to my knowledge, this is not a feature on the actual moon. It would have taken some bracketed exposures to try and get features on the moon itself. So here's the photo commemorating the diamond ring phase as the eclipse was about to start. And this is an image I put together in an attempt to show what it's like during a total eclipse, what it's like outside. And it's a different color, and it's a different twilight is everywhere. With the clouds, I didn't get very much in terms of light. Over there, Venus appeared. That was about the only other celestial object I was able to see in the sky, but I did get to see totality. And so, how badly did I botch this? This was closer. I went and took some pictures with the moon in the sky. You know, we have this crescent, which we're going to see. This is a little later. This is in a 16 millimeter lens. This is how big the moon really is in the sky. When you take a wide angle view, that's it. So if I were to redo these images, this would be a whole lot smaller. And so there you go. That's
really beautiful.
You take these pictures because you want to see if you can manage enough light to be able to see constellations, stars, or you may want to be able to see something else that's going on in the sky along with the moon itself. And so that's where, now this might be a horrible composition, but it will lead to something as we continue to try and work on images, testing new equipment. There's red spikes here. Some of you may know where I'm going with this now. This was maybe a week before May 10th, 2024. And a lot of you saw this aurora. It wasn't this dim, or these spikes. This is what I'm used to seeing when I do distant aurora. I go, oh, I caught it. And so chasing aurora was not always something that I would look to do. I would try and get some detail working on my compositions. Cygnus region and the beginning of the bulge of the galactic center is always a great test of your longer exposure composites. And if you get Barnard Z, which this should sharpen up here, if you can get a good image of Barnard Z, you have a sharp image. Your sharp Milky Way image shows up here. You've got the northern coal sack, which was off screen there. And you can still sometimes, overdo it with your noise reduction. So you just have to be careful with that. But this is, and then you can have some other artifacts happen in your images, depending on how you process it. But this was the side of the road. It was pretty dark, and my first shot on the galactic center. So that was nice. So let's talk about this image.
Wow.
As I'll start to wind down, because we're into the aurora phase of the changing cosmos, looking up. Many of you saw this as far south as Arizona, South America. This auroral outburst was pretty well amazing. Make sure I've got the screen. So it's pretty well amazing. This picture represents one of the more amazing times for me, because I didn't see all of this color, but I did see a lot of these streaks, and I realized that this curtain is essentially right on top of me, because I saw the light shining before I looked up to see the curtain. This is a curtain that's on top of me, and to where I've got it all going to a point. If somebody's taking an image of this aurora, it is from a distance, I'm standing underneath that image in this picture. So that is, to me, it's even more amazing than the colors and everything you're seeing. Is this is right on top of you. And how often can you say that you look straight up? Those of you that have seen aurora on top of you have seen something like this. You've stood under the curtain, and when it goes into a point like that, that's an aurora curtain that's on top of you, and you are a part of whatever picture someone took of that particular curtain. You're underneath it. It's high up in the atmosphere. You're right below it, and so you're a part of whoever's aurora picture was being taken in the distance. Now, this is an attempt and you'll have to pardon the processing from Google Maps has, apparently played a role, but you can see all four of the colors, the pinks, the purples, the whites, and the greens. It simply exploded. And this is a composite because this is an attempt to show all that practicing of getting a getting an accurate earth shine so that I could show what I saw with my eyes. And that was the whole point of doing that. That is an accurate, the 16 millimeter lens. That's how small the moon looks in the sea, a wash of color with aurora images. So now, and of course, looking straight up, many of you saw Corona Borealis. Again, the aurora is right on top of you. So we take pictures, and when you can take pictures and the aurora is still raging, this is my good friend Brian Autumn, whom I hope to bring on at some point. And this is another photographer. We just continued to take picture after picture. That was the scene before we could at sunset. And all the other pictures I showed you was the scene after it got dark enough. And this is a panorama of people just watching this show as it goes. I did manage to get some starlight. Gemini's right here. Orion setting through the moon. All of this was going on. This is Lake Huron on the Canadian side.
That's beautiful.
And then as it starts to dissipate, it's still going on. We're still taking pictures and time lapses. And there I am looking at it. This is, for those that still haven't managed to see Aurora up close like that, this is a true color picture of what it looks like. The purples, the reds, the greens that you can see. The camera picks up a little more than your eye, but these colors are a little more muted than I had. That's essentially, this is what your eye sees. This is the color that your eye sees when the aurora is that close. That's what your iPhone tries to do. Some more of these pictures here. The curtain, the telltale curtain of aurora and clouds coming in. We ended up leaving because more and more clouds came. And so the next night, this faint aurora over this lighthouse and flowing water here, it was a bit of a letdown. I can still see the aurora, but now that I've seen it up close, it makes the pictures, not quite as interesting. So we still find ways to capture Cygnus. So even if we don't get the center of the galaxy, Cygnus is a very good way to shoot. So we end our journey. We went out west to Bull. We stopped by Meteor Crater, and this is a panorama I took of it. This little blotch right here is Omega Centauri. If I had an EV scope, I'd have a much better image, but this is one of the images that I'd hoped to get. I'd been searching for it north, but I realized I was at 31 degrees north latitude. There's Omega Centauri kind of turning color as it's setting. This is a very low southern horizon at 31 degrees north latitude, and that blotch represents a milestone. I've finally seen Omega Centauri and a lot of the stars of the Centaur as well. And I had to try and find it mostly manually. And this is under the light of a full moon, which there's the full moon. I took the image of it. And again, looking for details. The more detail you get in a shot without having to edit it, the sharper your full moon picture turned out. And so with that, Scott, I know I'm probably running well over time. But the journey
15 minutes over, but it was pretty exciting to see your images, especially the auroral images are just really so beautiful, So
yeah, those images make themselves. I always end up with, if it wasn't for the cosmos, what would we take a picture of? And I always say we should defer to what it is. because that makes the beauty all of its own. And it gives us something to discuss, to talk about, and share. But I'm always all for, talk about what you're capturing, and a little, your processing can be great, but what you're capturing has to be there in the first place.
That's true.
So,
That's
so
true.
there you go, Scott.
All right.
I will.
All right. Well, thank you so much, Adrian,
There you
for
go.
coming on and sharing once again on Global Star Party. That's great.
Thank you for having me, Scott.
Yep. Thanks. Okay. So up next is our one of the real experts of lunar terrain and the moon and lore of the moon and the science of the moon. Someone that keeps us really tantalized by observing the moon, and certainly you spend enough time with this guy and you can learn to really love the moon so much. I'll share something with you that when I first started amateur astronomy, my main interest was galaxies. And so, the full moon would come out, or there would be a lot of moon, and I would start to get disappointed because of the moon's glow up in the sky. But the first thing I ever saw with the telescope ever was with my little 40 millimeter Kmart telescope, and it was, of course, the moon. I was able to reappropriate not the same exact telescope, but one identical to it. And I turned it on the moon, and I had this rush of excitement again, and it reminded me why I got so involved in amateur astronomy to begin with, and now it's become this lifelong passion. So, Robert, thank you for coming on to Global Star Party, our 150th. And
I'm honored to be here on such an occasion. And your a relation of your introduction to astronomy through a small telescope in the moon is a very common thread through amateur astronomy. The moon is what got most of us involved in astronomy, because when we didn't know anything about the sky, it was the easiest thing to find. And reverting back to Adrian's pictures, he was saying he's shooting with a 600 millimeter lens, handheld. It reminds me of how astonishingly forward we've come in photography. I try to shoot at 6,000 millimeters, not 600, and here he's getting marvelous images handheld. And that immediately flashed me back to the Eclipse, because I went up to the Eclipse in Dallas at the Frontiers of Flight Museum and set up a Celestron telescope like you normally do to do photography of the eclipse. And I thought I had a pretty good setup going here. Snap, snap, snap away. And then afterwards, I look over at my friend Rachel Freed, standing not too far away with a little handheld Canon Power Shot with one of these super zooms on it. And she's hand holding these pictures of the eclipse that turned out just as good as what I took through the Celestron telescope. So, I have been so outclassed.
Yeah, they're getting better with it, but I'll tell you what, the bigger your aperture, the more detail you ultimately can get. But so image stabilization goes a long way to being able to get those handheld. Otherwise, our shots would be all over the place. So we are cheating a little bit.
Well, they're pretty darn good. Anyway, getting on with what I'm doing tonight. The theme of the show is, of course, ever-changing cosmos. Well, the moon has been ever-changing as well ever since it was initially formed. And I do not see anything here to, oh, there it is, the share screen. It finally popped up. So let's see if everything works out okay here. My usual postcards from the moon introductory slide. Is it visible?
Yes.
Great, it's working today. Yeah.
Yes.
Well, good luck on the 150th. Now let's too many advances. So my usual mandatory slide about the moon, where I explain there are only two primary landscape forming processes that occur on the moon. Unlike plate tectonics and weather and oceans and stuff on Earth. On the moon, everything you see on the moon's face, whether with the naked eye or through a telescope, was either created by an impact or volcanism. So we keep that in mind as we look at the features on the moon and use that as a guide to decipher what we are looking at, how to understand what we're looking at on the moon. So the moon is ever changing. Of course, we get to see it change night by night as the phases grow. And I don't know why it's taking so long for my slides to advance, but they're getting there. Anyway, the shadows change night by night. The libration changes a little bit, and we get to speak around the edge of the moon a little bit. And we go through the phases from new moon to full moon, then start shrinking back down again through the phases again. And we follow the terminator where the shadow line is, the sunset or the sunrise shadow. That's where we see the greatest detail because of the relief from the shadows. At full moon, we see more of the lunar disk, of course, but it's very flatly illuminated, no shadows. So we don't see very much. And then finally, the moon gets back down to the thin crescent before new moon again. This is what I call the Cheshire cat moon, because we all remember the story of the fabled cat, the magic cat, in the story of the Adventures of Alice in Wonderland, where the cat just slowly faded away until all that was left was his little crescent smile. And that's what the crescent moon reminds me of so much. But, whoops, there we go. Now it's advancing. Ever-changing moon. Now, we have to realize that the moon is not the primordial object that we thought it was before the space age. Back before the space program, where we got to investigate the moon close up, eventually land men on the moon. It was pretty much assumed that the moon had been unchanged since the beginning of the solar system, and that it was this storage locker of pristine geology that has been unchanged for the past 4.5 million years. Well, we now know that that is not the case at all. The moon is an object that has been stomped on, crushed, beat up, kicked around by the solar system, and it is far from what it was when it started. And we're going to go through a little bit of progression of time to see how the moon changed so much from when it was originally formed 4.5 billion years ago to what we see today when the pretty full moon rises above the eastern horizon. Now we divide lunar time up into a period of 5 epochs. Anything older than 3.92 billion years is considered pre-Nectarian. And then there's a very distinct period of time on the moon, the Nectarian epoch, begins with the creation of Mare Nectaris, or excuse me, the Nectaris basin that now cradles Mare Nectaris. Now, if you see my cursor, this is Mare Nectaris right here. That small basin was created about 3.85 billion years ago, began the beginning of the Nectarian epoch, a period of late heavy bombardment where the entire solar system, inner solar system, was bombarded by thousands and thousands of asteroids and comets. That only lasted about 100 million years. Then we entered the Imbrian epoch, about 3.85 million years ago to about 3.1 million years ago. During this time, extensive volcanism formed the face of the moon that we see today. And then for about 2 billion years after that, the Eratosthenian epoch, where all the post-Mare formation cratering occurred. And then the current epoch, from about 1 billion years ago to now, the Copernican epoch essentially began with the formation of Copernicus crater and continues to today. So throughout these epochs, the moon underwent a metamorphosis. This is the moon of 4 billion years ago. This is a Don Davis painting. Don Davis is not only one of the authors of the Big Whack theory of lunar formation, he is also an extremely talented space artist. And his visualizations of what the ancient moon looked like are very useful. You look closely, you see very many familiar features. You can trace the outlines of where many of today's Maria are by seeing the basins that they originally were formed and now cradle those Maria. You can also see a number of familiar craters because these ancient craters are all pre-Nectarian. They still exist today, have been in existence for over 4 billion years. But back before the Nectarian epoch, about 4 billion years ago, this is what the whole moon looked like. There were no fields of lava creating the caricature of the face of the man on the moon. The entire moon was a crater-pocked total wasteland with no personality. As seen from the Earth, it was a featureless white ball with only the phases to show any difference. Of course, there were no human beings back then, no life on the Earth at that time, so nobody to see it. Now, moving on to what the moon looked like back then, we have examples of that we can see through the telescope now. Regions like the southern highlands that nest in between Mare Nectaris and Mare Nubium represent fairly faithfully what the entire moon looked like 4 billion years ago. And we can look up with any telescope, even a small telescope, and see this cratered wasteland even today, because this is the highlands. Higher altitude was not flooded by the basalt that flowed during the Imbrian epoch. Okay, then we enter the Imbrian epoch, about 3.1 to 3.85 million years ago, and this is when a majority of the volcanic flooding occurred on the moon, and it paved over the low-lying basins and created the dark regions that today we see as the face of the man on the moon when we look up at the moon with our naked eye. So the moon immediately, over a period of only 1 billion years, takes on an entirely different face. And now we see those Maria here in the Mare Nectaris, now no longer a basin, but a smooth lava field. The same with Mare Humorum on the opposite hemisphere of the moon, or Mare Imbrium, which forms the man on the moon's left eye as we look up in the sky. And the west-eastern shore of Mare Serenitatis that helps form the man on the moon's right eye. During this time, there was a long period of volcanism, lasted about 1 billion years. We can see other manifestations of this volcanism by the dark ash deposits around the little cinder cones inside of Alphonsus crater. These can be seen in a very modest telescope. At 9 o'clock, 3 o'clock, 5:30, I've shown this picture before in other presentations, but it again illustrates the change in the moon over a period of millions and billions of years, ongoing volcanism changing the face of the moon. And further up north, more Mare formation, the craters paved over with basalt, the higher elevation craters, in this case, Aristotle's and Eudoxus, high enough that the basalt didn't flood it, but the crater Edge D, just to the east of Aristoteles, you see it's been partially flooded with these basalt flows that flowed shortly after the Nectarian epoch. And Gassendi and Latrone craters. Gassendi is the oatmeal cookie looking crater down on the bottom, floor fractured crater heavily modified by volcanism. Latrone is the horseshoe bay to the northeast of Gassendi. Two similar sized craters, about the same age, 4 billion years old, yet location is everything in real estate. Here we see that Gassendi was high enough that it wasn't flooded by basalt from outside. Instead, the basalts welled up from underneath it and created a floor fractured crater, whereas Latrone on the southern rim of the Procellarum basin was flooded with basalts that formed Oceanus Procellarum and turned it into a horseshoe bay. And we get up to the Nectarian epoch, the modern era. this is marked by any crater that you see on the moon that still has a ray system is less than 1 billion years old and is of the Nectarian epoch. Crater rays, the bright splash, snowflake-like splash that scatters around some craters like Copernicus, Kepler, Tycho, they have a limited lifetime. They only last about 1 billion years and then they fade away because the continuous infall of meteorite and the solar wind and coronal mass ejections have a big effect on the moon, and they slowly erase the rays and they go away. If they didn't, well, the moon would be just another solid white ball again, because every crater would have a ray, and we would no longer have the contrast to pick out features. But moving along, of course, Copernicus was called the monarch of the moon by the ancient observers when they first put telescopes to astronomy. And it's surrounded by a ray system that spans almost 1,000 kilometers. It splashes across several of the Maria. Kepler crater up northeast of, or to the west, I mean, of Copernicus. Another classic. It's smaller. Its rays are not as large, maybe 500 kilometers across their far reach, but the individual spokes of them extending to the west are very distinctive. And of course, Tycho down in the south. The Tychonian ray system spreads across the entire southern hemisphere of the moon. Tycho is the youngest large crater on the moon, and you can see it by all of the rays point back toward Tycho. And Tycho formed about 1.8 million years ago. It's a youngster compared to most lunar craters. So its ray system is still very fresh, and it splashes across 2,200 kilometers of the southern hemisphere of the moon. So we are, here's a close-up of that ray system. You see how it just splashes out across the whole southern part of the moon and makes Tycho look kind of like the navel on an orange, the little spot where the stem used to be. There we go. Another look at, as we wind this up, another look at Tycho and very low sun elevation. And here we don't see the rays. Rays reflect brightly back toward the light source that is illuminating them, which is the sun, of course. And thus, rays are brightest when the Earth is between the moon and the sun, which occurs during full moon. But at local lunar sunrise, that reflection angle is off to the side, and we don't see the rays as good. But what we do see in this picture are the thousands and thousands of tiny, tiny little pits all around Tycho that have not been eroded away yet by space weathering, that infall of meteorite, constant meteorite infall, or the solar wind. And here we see the evidence of the Tychonian impact, where the explosion that created Tycho 108 million years ago showered the entire region with rocks and boulders and debris, creating thousands of secondary craters, and they're still visible. So this is one of the youngest large features on the moon. We've gone through, as we trace through this, a geologic period of time, literally from the birth of the solar system up to just a blink of an eye ago when the dinosaurs roamed the earth. Many a T-Rex was startled by the flash that created Tycho in the sky. So this is spanning virtually the entire age of our solar system by looking at the different features and understanding the different features on the moon. Whoops, I forgot I had one more Tycho in there, but it kind of repeats things. So I'll end with my usual slide that says there is much to love on the moon. I consider the moon to be my playground, and I invite you to come join me on my playground. And a brief moment to say that if you enjoy what I present here on the moon, want to learn more about it, please go to Amazon and do a title search for Exploring the Moon with Robert Reeves. and it can be on your doorstep in 2 days. So with that, I'll turn it back over to Scott, and it's been a lot of
Okay.
fun.
Okay. We do have a question here.
Alrighty.
Beatrice, watching in Belgium,
Oh,
she's watching on YouTube. She says, "Does the difference in Earth's gravitational pull um, on the near side and the far side of the moon heat up its interior? Is there any evidence of current geological activity on the moon?"
uh, there is ongoing moonquakes, and the not volcanism, but moonquakes. But it's debated whether or not that is being created by Earth's gravity, because yes, there is a difference between the gravity on the near side and the far side, just like there's a difference on the moon's gravity on the near side and far side of the Earth, and that's how we have the ocean tides. But early on, the moon was much closer to the Earth. When the moon formed 4.5 billion years ago, it was no further away than today's geosynchronous satellites.
Ooh.
So the gravitational tides on the moon were fierce back then. The moon was being crushed and squeezed and literally like rolled up in like a dough ball in your hands by Earth's gravity. And I'm sure that contributed considerably to the volcanism on in the early moon. Now, once Earth's oceans started to form about 3.8 million years ago, the Earth cooled off enough where water could condense out of the atmosphere. The temperature of the Earth dropped below 212 degrees and water condensed, oceans formed. Once oceans formed, it is the tides, the Earth's ocean tides are what propel the moon away from the Earth. So early on, the tides were really fierce because the moon was close, and the moon receded away more quickly. But nowadays, 4.5 billion years after the moon's creation, it's out there almost 400,000 kilometers from us, and it is currently receding away from the Earth because of the ocean tides at the rate of 3.8 centimeters per year. About that far per year. Now,
Okay.
within that doesn't sound like much.
Well, it adds up, right?
Yeah, it does add up. Now consider that many of us were alive when Neil Armstrong set foot on the moon. One small
Yes.
step for man. Well, the moon is now about 2 meters farther away than it was when Neil Armstrong set foot on the
Wow.
moon. Now that's a measure you can feel that with your hands.
Sure.
That the moon has moved that far away within our lifetime. So it is a cumulative process, and it'll keep going as long as there are oceans on Earth.
Sure. Yeah, and that, by the way, I was corrected. That question was from Fender 90. But he has one more question. He says, "So I guess there were basaltic tides on the moon back then?"
I'm not well. There's Earth tides on the Earth today because of lunar gravity. It has been proven that the ground heaves up several centimeters because of the lunar tides. So when the moon was much closer during the Imbrian epoch, I'm quite certain that Earth's gravity did bulge and heave the more fluid basalts as they were flowing, just as the moon's gravity today elevates and lowers the Earth as the moon rises and sets. Now, this is such a small shift in the Earth that it's only detectable by the laser instrumentation that we've left on the moon and laser measurements. But the similar effect had to be reciprocal when the moon was young and much softer and more squishy because it was still warm. So yes, indeed, the Earth's gravity did indeed create physical tides on the moon by moving the surface.
Okay. All right. Well, thank you.
You
Thanks
bet.
for the great questions out there in the audience. Okay. Thank you again, Robert. And we continue to learn more and more about our closest celestial neighbors. So thank you very much.
You bet.
Yep. Okay, our next speaker, we're going to jump down to Brazil and speak with the Professor Marcelo Souza. Marcelo is the editor of Skies Up magazine. He is the architect of many educational outreach programs in Brazil and affects much of the scientific literacy in South America and around the world. It's great to be able to call him a friend, but if you ever met him, you would know how easy it is to make friends with Marcello. So thank you for coming on to Global Star Party, Marcello. It's an honor to have you on our 150th program.
Hi, thank you for your kind words, and the honor is mine. For me, that's a great pleasure to be here, and congratulations. It's a special day. 150 program is not easy to reach this. And then for me, ever is a great pleasure to be here.
Yeah,
Thank you very much for the invitation. Congratulations.
Thank you.
I think that not only me, but all the participants and are celebrating these special ephemerides. I will share here my screen. And also in the spirit, I may also celebrate another special moment because our astronomy club is celebrating 28 years of activities. We founded
Oh, wow.
the astronomy club on May 26, 1996. Then we have 28 years of activities. For us, it is a long journey already, and we had the opportunity to organize many events here in Brazil and with international invited speakers from 34 countries visited us, and we had the opportunity to have the participation of 7 astronauts here. 2 Apollo astronauts, that is Buzz Aldrin and Charlie Duck, 2 Russia cosmonauts, Pavel Vinogradov, Oleg Kotov, Anusha Ansari, that is a famous space explorer that visited the International Space Station, and the ESA astronauts, Paulo Nespoli, and the Brazilian astronauts, Marcos Pontes, and we have invited speakers from different countries, from all the continents. And one of the invited speakers was Scott Roberts, that also visited us. Thank you for coming for us. And in our history, we have many records of very special moments. And for us, it's a great pleasure ever when we show the pictures of the events we organized. We had the involvement of many young people, many students, and we hope that in these 28 years we had the opportunity to motivate the students to study astronomy, science. Then this is already for us is the history of the astronomy in our region in Brazil. That from 1996 we begin to write a new history of science in our region here in Brazil, that we are located in the north region of the state of Rio de Janeiro in Brazil. And these images show parts, a small part, a very small part of the activities that we organized here. And last week, I was invited for the third time that I participated. This we have an event in Brazil that's called Pint of Science. I don't know if it's an international event or only in Brazil, that we talk about science in restaurants, in bars, in different places. These are, I was talking about astronomy in a restaurant. Né? And you had this happen during 3 days in many cities in Brazil. Né? People go to the restaurants and have opportunity to know about science. And as a celebration of our 28 years, we make participate inauguration of a new nucleus of our astronomy club near the beach here in a protected park that is the lagoon of Açu here in our city. It's 50 kilometers far from downtown. Né? And here is the inauguration of this nucleus of our astronomy club and also a nucleus of the dark sky Rio de Janeiro there. And we also organize an activity of solar observation né,
Great.
near the lagoon. Né?
Mhm.
You see many people with the clothes to take bath in the lagoon. And this was one of the celebrations of a celebration that you organized. And this was the main celebration that this is the observatory that was inaugurated in another other protected area that's a park, né? Is a reserve, né? That protects
It's your
a
new
forest
observatory.
near the
Yeah.
ocean. Né? This is the observatory, and now it is working. Né? It was inaugurated during the celebration of our 28 years. We had the opportunity to test the telescope that is controlled by the Our Sky. Is a project that involves Our Sky. And thank you, Scott, again for Scott that was responsible for this opportunity for us, that introduced us. Thank you very much,
I'm
Scott.
glad it all
And
worked
now
out. That's
the
great.
observatory is working. Here, our club inside the observatory. My wife and the other members of our astronomy club there.
Mm-hmm.
And here is the telescope and the system. We have everything is automatic. And the roof, you can control the roof online. You have a camera inside to see what is happening inside the observatory. And also the telescope is controlled online. And here is all the system, the camera, the focuser, and the pier, everything that and this we have energy, you have Wi-Fi there, you have a cable internet, everything, and it's a remote place, né? Far from many places, far from the city, né? That located is a telescope, and I will show now the first image that was taken today.
Wow.
That
Nice.
is Omega Centauri from the telescope. Né? Then it is working. Né?
Oh yeah.
We are very
Very
happy
nice.
that is have the opportunity here to have an observatory. Even that this telescope, most of the time, will be used by controlled by our sky and used to other groups. We have a part of the time, a small part of the time, for our to begin research here in our city. Then it will be an opportunity for the students here and the teachers to use this telescope to begin research here in our region. And I would like to show something that I don't know if you already saw, because everybody knew what happened with these big sunspots, né? At the same time as the Carrington sunspots, that is the AR 3664. That's a big one, né? And you have a big solar flare and a CME that arrived on Earth in May 10, né? That were registered in United States, in many different places in South regions, né? Of United States, but also I have something that I didn't imagine that one day I received a report about this. These are this is not this flare. This is a flare in May 11. That is a X 5.8. You have a May 10 and the other one in May 11. That we also had one that is X 80.4. That was the strongest one, but it was not direct to the Earth. Was in another direction.
Mm-hmm.
And this was that I saw, that I said, that are images of the Aurora Borealis in Mexico. This image was taken by Thomas Calvario from the Observatory Astronômico Nacional de Mexico. It's something that I never imagined that I will see an image from Mexico with Aurora Borealis. The latitude is 28 north. As fantastic
Wow.
images.
Look at this.
The Sol de Aurora in Mexico. That is something
Incredible.
almost unbelievable. But I also received reports, I saw reports in from space weather. They register auroras in Africa. Here in Brazil, nobody saw. Even in the south region of Brazil, we didn't see any aurora australis, but in Mexico, they registered auroras. It's something fantastic. I'd like to thank the Observatório Astronômico Nacional that allowed me to show the image. That's a fantastic image and almost unbelievable image. And you need to be careful because you have two big sunspots now. This one that is 3661 and the 3664 that's coming back. That today we have this, yesterday we had this big
Look at that.
explosion that is appearing. I think that's one today or 2 days more. We will see again these big sunspots that is returning. You have two big sunspots directly in the direction of the Earth. Then we be prepared because this was a X2. I don't, if I'm right, that happened 2 days ago. Then we need to be prepared because the sun is very active. And I don't know what will happen. And I am studying, as I am reading papers of experiments that shows that geomagnetic activity maybe can affect the animals and also the us. This kind of study, they interact with our electricity of our bodies and it can affect us. You have studies made in Russia, United States, and other countries that results in mouses that show that it's affecting mouses. Then I need to be prepared. I don't know, but anyway, we are safe because it's not will not is not something that will affect directly us in a short time. And let's see what will happen when these big sunspots can return. Then we are celebrating also the 28 years of our group. And today I and our group is celebrating the 150 programs of the Global Star Party. Thank you very much, Scott, for the
Thank
opportunity.
you. Thank you so
Ever is a
much.
great pleasure to be here.
Yeah, it's great. It's great to have you. Okay, all right. So we're going to stay down in South America and run down to Argentina. You have a great night, Marcello, and I know it's late there for you, so thanks very
Yes,
much.
thank
Thank
you.
you.
Bye.
Okay. Uh, Let's bring on Marcello, excuse me, Cesar. Cesar's down in Buenos Aires, Argentina, and he has nicknames. One of them is 100-mile-per-hour.
Yes, yes. But
100-mile-per-hour Caesar,
yes,
because he was out in the very strong wind one night, still showing us stuff from his patio. Okay, so somebody talked about, could you do citizen science with just a small part of the sky? And I think the answer is yes. You could probably do citizen science from a light polluted patio in the middle of a big city, like where Caesar lives. And the main point is to get out and do astronomy. And Caesar is the I don't want to say the poster child for that, but he is someone that's always encouraging people to get out and do astronomy, no matter what the conditions are. So let's bring you on, Caesar. Thank you for coming on to the 150th Global Star Party. You've probably done almost 100 of these by yourself, so thank you.
thank you, Scott. Thanks by inviting me. Really, it's a big number, 150 star parties. And really, yes, more than 100. I sure that I been.
I think it is more than
Yes,
100.
I participate, and
Yeah.
I participated in many, mostly. And yes, for the startings for in the pandemic, in the pandemic situation, it's incredible that we was continuing and working, showing the sky to the people, make science. It's for me, it's a honor. I am not a science guy, but I'm not a professional science, but I'm proud. It's a honor to share the sky, and as you tell, it's great encouraging people to use their own telescopes in conditions where in the past all people thinking go to the maybe a weekend for a outside from the city, out of the city areas with more clear skies, and telescopes mostly of the time were in the in the boxes without use. Today, all the technology about go to mounts, and of course astrophotography, is an opportunity to use our instruments in conditions that in the past, maybe no more than 10 years ago, because we are in the revolution of technology, we can use in middle of the cities where most of the people and amateur astronomers live, the opportunity to use their own telescopes, and take some pictures. Maybe are not the pictures with a quality that you can get in a mostly clear skies or dark skies, but with a new concept of processing image, or maybe using your camera like electronic eyepiece. And actually, some company launch electronic eyepiece. It's not the first time that exists something like this.
Pegasus Smart Eye, that's the name of it.
Yes. Thank you, John.
Thank you. Hi.
Hi, John.
Sorry to interrupt.
Oh, no, you're welcome. And really, the situation where you have a camera, this is a CCD camera, but you can use planetary camera, CCD planetary camera that is cheaper, or your old reflex camera that maybe for some people tell me, I have a reflex camera. Sometimes I told to the people that buy only a mount and use and connect their own reflex camera and starting to make the star trail, the tracking of the sky, to discover places of nebulas or, many things in the sky, many treasures in the sky. Because maybe if you go to the dark sky area, you can make a draw and enjoy with your eyes a nebula and star cluster, double star, and you can draw, for example, like make a beautiful drops of treasure of the skies. But in the city, sometimes you mostly see, or mostly, maybe I can say, you don't see the complete object, and the helping of technology of an electronic eyes like a camera make in your computer image where you can enjoy more the shape, the brights of the gas nebula, or maybe you can see a galaxy. And of course you need clear sky. That tonight I send you a message by our right Zoom, where the entire day from the midday to the dusk in the evening was totally clear, and now you have fog. But of course that I make a presentation, I have a presentation to show to the people, and mostly next week, or I have prepared this my observatory balcony. Of course, I hope that next Global Star Party I can show to the people a live image. Today I'll not show live image, but I have a lot of image, and I can explain how is my setup of this observatory balcony. And sometimes I go to the rooftop of the building, but mostly I use my balcony because I have some part of the sky here, and it's very easy and fast to make a setup because I have prepared everything, the position of the south. Sometimes it's something like I can choose between see something in the TV or take my telescope outside in the balcony, take some observations. This is the same that everybody can make with their own telescopes. Sometimes you have an entry-level telescope and you can put your cell phone. That is it's an excellent camera for astronomy. And sometimes, like Maxi started, you can use your cell phone to make, of course, that planetary image is excellent. And two, you can make very good dark or deep sky image with a cell phone, with a regular cell phone. This is very interesting. It's a golden age of technology where we can use a lot of different things to make astronomy, and things that help us to use our telescopes in middle of the city with a very, very high light polluted skies. For example, I will share the presentation that I have.
Yes.
I'm start from here. It's like a resume of all that we made here from the balcony. An opportunity to explain to the people where I am, or how is my portion of the sky here in South America, in Argentina. Argentina is in the southern, like as Chile, we are in the southern cone of the continent. Here I have 34 degrees south. Is comparing in the United States, Atlanta, Georgia have a similar latitude. And well, the first thing is that maybe you can make the same of image as everywhere. Maybe, of course, very tiny galaxies with very low bright are not good for a light polluted skies, but of course that bright nebulas, solar, lunar, of course, planetary, of course, nebulosas planetarias, planetary nebulas, and the most galaxies. We are talking about, for example, galaxies that are in Messier catalog, because you are sure that with 90 centimeters or 100 centimeters, sorry, 4 inches or 3 inches telescope, you can start to have some image almost with a cell phone, smartphone, of bright galaxies, like, for example, the hot galaxy, Messier 104. Well, this is something like not tonight, but normally I can start to use in winter, and it's something that everybody can make from in your home, in their home. You can put today. You have a lot of technology that normally you don't need buy anything to use remotely your computer, where you receive the image of your camera and make everything with a cell phone, with a Google remote desktop or another application, and you can enjoy without take a lot of cold weather or suffer cold weather, or low temperatures, or the winds, like you told me, Scott, that I remember that day. Yes. And this is something that everybody can do it. United States, Brazil, and Argentina. Well, Brazil have Armaruki that make in the south, in the night of Brazil, they have a cold weather too. Really cold. And some parts of Brazil, maybe if Marcelo is listening, can say that is real. In the south of Brazil, mostly the continental areas with low mountains, but enough altitude to have very low temperatures. Maybe they receive snow. Maybe it's not something that for every year that is possible, but do you have the problem of the cold weather in astronomy, where you need to put a lot of layer sorry, the name of this, well, layers of well, sorry, I forget the word. We call it vestimenta in Español, vestments, or I don't remember the name, but you need to cover in layers of different clothes. dots. Well, I put in the presentation cozy drinks, hot drinks, and cool music, if it's possible. But you can go today like a professional observatory outside of your telescope area, and you can go inside really and move your telescope and take the pictures maybe from your bed. And this is a technology that is totally available for everyone. Well, this is my field of view because this is the limit of here you can see, I can show you the same. And it's for the telescope, I gained this area. But this is the top of the balcony that you can see here. But for the position of the telescope, I have this part of the sky too. And this is the point of the southern polar hemisphere, the south polar hemisphere. This is the point.
I see.
You can see maybe because with the same wielding, you can see the position of the Exos 100 mode. This is my setup from the balcony. Is the telescope of this observatory. This is the west part. Is for this area. I can show you. Yes, you can see because it's in opposite for me view, but it's the same shape of the wheel, like a stair. This is a first view where you can have the scale where I remember this was a conjunction between Moon and Jupiter in this part of the wheel. I like taking a scale between the things to explain to the people for things that you see in the land and compare to have a scale, because many people think that we use 1,000 magnifications, for example. And when you say, no, sometimes I use 20 times magnifications for one option, or start to explain that we think all in angles. For the people, say it's sometimes something like oh, I have this presentation in my store sometimes to show this idea of scales or how the things are compared with land objects. Well, this is one of my favorite pictures. Of course, that after see the Robert Reed's pictures of the moon, of course, that this is not something that I can compare. But well, okay, this was from the balcony, from the
that's nice.
With the Fairlight,
nice.
127 Maxutov Explorer Scientific Telescopes over a EX 100. It's a great optics. It's something like I tell to the people that that try all times from their homes, from their balconies in the city, that try to have this kind of pictures, because it's really really. I remember the name, it's like a prize, like rewarding. It's a I remember that it's a word that John teach me, and rewarding. And this is something that is for the people is very nice. You can share your pictures with the people, and it's a great time to enjoy astronomy. And this is Jupiter with the same telescope. This was the eclipse of May 222.
The annular eclipse?
This was the no, this was the
Oh, the
lunar
Right.
eclipse.
Okay, got it.
Yes, we are having annular eclipse next in the Patagonia. We are going to the Patagonia, to Santa Cruz. Annular eclipse, solar annular eclipse, October 2.
Nice.
Say the date. And this is the another configuration with the Eclipse 100. My Eclipse 100 is not the 2 because it's the maybe one of the first one that Scott Roberts sent me. It's before the pandemic. The pandemic is one of the first, and it's continuing. Is going to have 4 years old. This is incredible. Or maybe more. I think it's more because we are in May. I don't remember when you launched the EXOS 100, but maybe it was in 2019 or 18 maybe. But this one, this is the first that I received, and take for me one, and it's still working. It's not the 2, it's not the new ones, but
I see.
Yeah. Well, this is a beautiful sunspots that I took from the balcony with the mixing a celestron. This was in the pandemic. Celestron Matsutov of 4 inches. So,
do you drift align when you have to find your polar alignment, because there's no real star you can look at, right?
Yes, good question. A good point of view, because we don't have a polar alignment stars, but something that is very helpful. Watching you. I'm sorry, watching you. I show you a picture where, because something that is very helping is the Southern Cross. We align the telescope with the Southern Cross. That is excellent. In Australia or here, we can use the Southern Cross. Here you have, well, and 3 different, how do you say, 3 different
setups.
Yes, the same mount, but well, here it's a very old mount from the 90s. Only with yes, a classical. Sorry. A classical equatorial mount with a motor. In the middle, do you have CWBO planetary camera, EXOS 100, refractor, Seabody's Bonnie. I don't know how to use, because it's a brand that you have a different telescope. And the another one is with the reflex camera, that I use it a lot of times. Here is a moon, but not from the balcony. It's not from the window in my from my living room.
Yeah.
And here you have the Southern Cross. Here is now here you can see the top of the building that I have in my back.
Right.
It
Just barely.
just
Yes,
Slightly
and
to the
just over.
slightly to the
Yeah.
left, right? When you align, it's a little left of the cross.
you need to take the measure of this part
Right.
and extend 3 times and
Three
half
times. Okay.
and half, and you can use your fingers,
Mm-hmm.
and you have a roughly polar alignment. But we turn crazy sometimes to make a good polar alignment. But for the people, next time that I am having
Star party.
yes, a global star party, but a clear skies.
Right.
We can show how using the free application of this application that is a SharkCap or the PhD guiding software, you can make a very precise alineations, especially for South Hemisphere where we don't have a polar stars. But this is another thing that the people I teach to the people, use this kind of tools that are excellent, are really excellent, because in the but if you can enjoy something for a very short exposures with a cell phone, you can use the typical position of 3.5 projecting and put in this point the axis of the polar equatorial mount, and you have a probably but effective effective polar alignment. But if you need, of course, 1 minute and guiding, well, do you need a work more precise? And today, do you have with the same camera that you are using, you can put this kind of software that are free, the polar alignment. And the fun thing is that, for example, SharkCap have a upgrade where you need to pay to have a more easy polar alignment tool. But if you don't have money to pay for kids, or people that don't have money for pay an upgrade of software, you can use perfectly the free application tool of the same software. But of course, if I say many times for the people that in many software applications, do have a lot of solutions, and if you can pay, you are making a good support for the people that make this kind of software. For example, this here in Becrux or Mimosa, this star of Southern Cross, you have a carbon star that is the reddest, the más roja, the reddest star in the sky. That is this. It's very very red, really red, and it's a carbon star. This is something that is very interesting, because this is something like you can tell to the kids, and the kids discover this, and it's fantastic.
It's like Campbell's carbon star.
Carbon, yes, we call it ruby, like that.
Ruby, it's beautiful.
Ruby, yes. And this is 47 Tucana, and this is a picture. This is for the windy. This is the picture from the wind, 100 kilometers Caesar wind, Scott. This is the picture that we talk. Yes, because here you have the small Magellanic cloud with 47 Tucana. This is the picture for that night. This is history, Scott.
That's a good.
Yes.
That's a good mount, Caesar. Your mount is very strong.
Yes,
that's an Explore Scientific, huh?
Really? Yes, of course.
Wow, that's amazing, man.
Of
Wow,
course.
that's amazing, man. You got
I
some
didn't pay these
pinpoint.
guys to say all this stuff, okay?
No, you don't pay.
No, those
No,
are
no.
pinpoint stars for that much wind. I am shocked. That's amazing.
I think something about the astronomy gear. For me, is something like and maybe Scott enjoyed this. Uh, over the commercial things, exists something like we fall in love with some kinds of gears in every hobby.
Sure.
In many
Mhm.
hobbies, you maybe talk about the motor for the drone or and start to say in this how do you say, in this
Hobby.
hobby,
Sorry.
but in this level of mount,
Oh, right.
level of price and payload, this 110 is going to say that the people tell me, for example, I say, okay, I sell this for 7 kilos. I tell you that this is 5 kilos, 7 kilos. I love this mount, but make your, for example, for a customer, for a future customer. When the people say, oh, I investigate all in internet, and this is a lovely mount. And for me, I prefer don't talk because the people don't believe me that they say, no, I have one in my home for science for 4 years, and this is a gear that I love, for example. And it's the problem when you love with the same hobby that you sell, you love. Say, oh, I need one for me. And this is something like enjoy and share with my customers. And this is beautiful, really, because it's beside it's in another level that only something only commercial, because
And
I
it's
have the
helpful.
same hobby. Totally.
It's so helpful because you're using this equipment so you can recommend, the level of, where they should start. And that's the best part of it, because you actually use this stuff so you can recommend the right equipment for people.
Totally, John. And sometimes when the people investigate in internet videos and say, oh, I found many things very positive about the gear that you recommend me. And for me, I feel really proud because it's not only me, and I think that is great because in the background of this mode exists a lot of people that make a different design and put of course a different things out of the box, how this mode work, that is different because the 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 functions of the modes are different, and this is great, really. In another this slide, this picture is Eta Carina Nebula with a big open cluster. Of course, this is I think that is I don't remember if I took with my reflex camera maybe 200, yes, 200 millimeters focal length, and here you have, and I like to show for the people the scale, how big are the nebulas.
That's huge.
And it's huge. Orion is maybe 2 times the moon, and Eta Carina. Here I don't have the complete, the complete or the quantity of exposure that I need to show more of this nebula. But the best part is that you can share with the people the idea of scale, how big or small are the things in the sky. And here, yes, you can see the tracking in the building. This is this part of the sky, and this is well, exactly here. Is esta Karina falling?
Wonderful. Well, Caesar, we need to move on in our presentations here. We've got Rodrigo Zeleda coming up, and Navin, who's staying up late although you're staying up the latest right now. So,
No, excellent.
yep,
That's passion, baby.
yep, yep.
Yes.
But I appreciate you coming on to the 150th Global Star Party, Cesar, and for
It's
all your contributions and for being on over 100 of our programs. So thank you so much.
Thank you to you and the
yep.
audience, Scott. I'm happy to share this. I continue watching from my bed.
Okay.
Because here is a little cold in the balcony, but I make the sacrifice to show the things from the balcony.
I appreciate
it's
it.
a tradition in our star
In
parties.
your
Yes.
Wonderful. Thank you so much.
Thank you
Awesome.
so much. Good night to
Okay.
everyone. Good night,
Good
John.
evening, Caesar.
Thank you very much.
Okay. All right. So our next speaker is Rodrigo Zeleda.
Hi, Rodrigo. How many times?
It's been a long time
Rodrigo?
since Rodrigo's been on. He has
Happy to see you, Rodrigo.
he has a retail store in Chile, and it's called North Optics. And but Rodrigo has also transitioned from being an amateur astronomer to a professional astronomer, and so that's really excellent. And I think that he's also quite involved in the astrotourism that goes on in Chile. And Chile, like Argentina, has very vibrant astrotourism programs going on, and Rodrigo's right in the middle of it. So it's been fun over the years seeing Rodrigo send me photos of him and his daughter doing astronomy together in his backyard. And it has been a little while. It's been some months since you've been on. So, Rodrigo, thank you for coming on to the 150th Global Star Party.
Hi, Scott. Can you? It's great to join us this night, and I'm very happy.
Me
It's
too.
a long time. I share with you my experience when with my daughters in astrophotography,
Yes.
using the new telescope DART 2. It's a smart telescope. It's
Oh.
very popular.
Oh, yes. Yeah, this
This-
this one. This
Yes.
one right here. So,
Yes, yes.
right.
Todavía no
daughter-
tengo el mío, Rodrigo.
My
Yes.
daughter loved it, this telescope.
It's
That's
fun.
the dwarf. The
That's
dwarf
the
telescope.
dwarf. Yeah,
Nice.
that's the dwarf.
This is
So, it's
very
ultra compact, it can fit in your backpack, and you got a little tripod with it and all the rest of it. So,
It's a complete telescope with a go-to system, telescope with a periscope system. This is the lens, the sensors, motor system,
Yeah.
and it's smart and go to the star. The very simple model in
yeah, you
5
just set
minutes.
it down and it aligns itself, and
It's-
you operate it from an app, just like you do. All the smart telescopes work this way to some
Are they
degree.
plate solving, Scott? That's plate solving?
Yeah, they do
Yes.
plate
Yes.
solving.
Yeah.
automatic plate
Wow.
solving.
Yes.
And I
We use
te-
one incredible.
with my daughter, I teach she the functions, and 2 weeks ago they first photo for the deep sky is my daughter 8 year old, and share with you just his first photo.
She's already taken pictures at 8 years old. That's amazing.
Yes.
Yes.
This you.
Wow.
Wow.
This is
So-
the
Check this
photo
out,
for my
guys.
daughter.
Holy
8 years
cow.
old. Okay. 8 years old.
With the
No,
That's
dark
brilliant.
too.
Increíble, increíble. Te
For
felicito.
my backyard.
Wow.
2 weeks ago, the night is very cold. I put the telescope in the backyard and Wi-Fi with my smartphone, and this my daughter click and go to the Omega Centauri. Yeah, she see the screen and wow, this is a globular cluster. In a few
Wow.
minutes.
Great.
Es algo, something in more simple to the photo and know the universe. Another question, another topic I share with you. This week in Chile, this week in Chile, I read the more big digital camera in the world. Is did you see the picture in?
It's still on your daughter's globular star cluster. Yeah.
Okay. This?
Oh yeah, we got.
Yeah.
Okay.
Amazing.
This week, I read to Chile in La Serena, the more big camera for astronomy in the world. Is the world big camera. This camera is work in the Vera Rubin Observatory in La Serena.
Uh-huh.
The last week I go to the party for my daughter, and the father of your friends work in Vera Rubin. He tell me now the telescope is without camera, and now he works is mount the new camera for the next year. This big camera work in the Chile is
3,200 megapixel.
The lens is
Crazy.
1.5 meters. The lens.
Wow, that's huge.
Yeah.
This lens, this
1.5
lens
meters.
is a big
refractive
camera.
lens.
Yes.
Wow.
Uh,
It's like maybe a Petzval
Oh
design.
man,
see, this is the camera.
That's
Did
a
you see the
big
picture?
camera.
This Monday I read to La Serena in the North Lab.
1.5 meters is like 59-inch refractive lens.
Jeez, that is got to be
That
so
is
heavy.
got to be a world record of some sort because
That's King Kong's camera.
they didn't make much larger refractors than like the 40-inch,
Wow.
right?
Yes.
And it was because the glass would sag under its
Yeah.
own weight, you know.
Who is the diameter, Rodrigo, of the lenses?
The
first
lens,
One
the lens
meter?
is the 1.5 meters.
Wow.
Jeez, that's
Wow.
incredible.
Well,
The lens
It's
of the
almost as
camera.
big as the 60-inch at Mount Wilson.
yes,
Yes.
yes. Now is going to be the biggest refractor in actually working, because at the time, for example, the double refractor of half meter each, it's in San Juan, and I visited the last year. This was the biggest refractor at but now is this in working in functions, and now this is totally incredible.
Yes, this camera work in this telescope in Cerro Pachón, near to Cerro Tololo in La Serena. This is a wide field telescope.
What's the F
to-
ratio? It's pretty fast then if it's a wide field.
Yes, wide field telescope for the map. It's a survey telescope for the.
Okay.
In a week, photograph the outer sky.
Wow.
You see, in one photo is 7 moon field.
That's huge.
Yes, it's
And this is the
most
Vera Rubin
Vera Rubin
Observatory.
telescope.
So,
Yes.
and those of you that don't know who Vera Rubin was, she is the one that pioneered the idea of, or one of the pioneers of the idea that the universe is largely made up of dark matter.
Yes, this
So
is
she was observing galaxies and the rotation of galaxies, and she felt that the stars on the outer edges of the galaxy should be
Slower.
Moving, much slower, and also receding from the galaxy mass itself. But it wasn't.
No.
Somehow all the light emitting parts of the galaxy were being held in to the gravity of something which they could not detect.
It's like a tether ball almost, everything rotates at the same speed, even inside near the black hole as well as on the edge of the galaxy, which is mind-boggling to think about because that's like defies normal thought, right?
Yep. So it was a big mystery then. It's still a mystery now what it is. But they are in the search for dark matter, of course, and dark energy, which I now think is thought to, be an even larger component of the universe. So
That's right. I think I remember, Scott, on Cosmos season 2, they highlighted the galaxy, the modeling of the galaxy,
yeah,
and what would happen to the galaxy if they removed the dark matter component and the galaxy just
flies
flies
apart, right?
doesn't hold
Yeah.
itself
Wow.
together.
Yeah.
That's some serious force.
Scott, I want to show you the 2 years ago. I working for the imaging of the Vista telescope in Paraná.
Okay.
It's another survey, and last
This
month.
is Paranal. Okay.
It's a little telescope. It's a survey like Vera Rubin, but little not bad as Vera Rubin. And when the Just West telescope take the pictures to the Tacarín Nebula with my professor, I composed the light imaging of the Just West with imaging of the Vista telescope. Is okay.
Wow, beautiful.
This is a picture.
Wow.
The with Vista telescope is a similar angle for the imaging to the James Webb.
What object is that we're looking at? That's the tarantula?
Yes, near the tarantula.
Okay.
Is this image? You see the picture?
Yes.
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 This is the first image is from the Earth in the Vista telescope, and the second image is just Webb. Do you see my screen? Yes.
we see a blue
Giant,
six
yeah.
inside image.
Yes.
Sí.
Mhm.
This is the last study of this project, the Vista telescope, and this comparison for the some object with the James Webb and the telescope in there, and this.
Oh, right. I've seen this field. Yes.
Yes, this is the
Did you work on this one as a professional astronomer? This was one of your projects?
when I studied diploma for astronomy, I contact for astronomer and work for the images of the Vista telescope, and I co-author in some papers. I process the data for the images like this for the Vista data. This telescope is a survey. I produce many data, and the astronomer tell me a very data we need to work, and I work with this image for process the visible images. The Vista work in infrared, and I compose the RGB image with the bands of the infrared.
It's very nice work.
And this data, this image, the astronomer using in the studies for presentation the data. And I work more co-author for the little papers with them. This is
It's a
my
lot of work
presentation.
you have to do with these.
Yes. When my work is neuroptics. Neuroptics, my story in Chile. Now my client is a serious astronomer, and our friend built the observatory in Atacama, and clients for another city of the Chile put your his telescopes in Atacama and view the images in remote control. Is the low cost costing telescope in Chile. In el South Observatory is Optes is very expensive for the Chilean astronomer, but my friend built the observatory in Atacama for the Chilean astronomers. The low cost is very good costing telescope.
Wonderful. Great.
This my presentation is good.
Thank you
Thanks.
so much, Rodrigo. Thank you.
Thank you.
That's great. That's great. Okay. So our next speaker is young Naveen Senthil Kumar, and I'm very proud to say that Naveen will be interning here at Explore Scientific here pretty soon, and so we're really happy to have him actually at our facility, and hopefully he finds that rewarding. So, Naveen, thank you so much. So, what is your presentation tonight?
So my presentation tonight is going to be about the evolution of the universe.
Okay.
So I have some slides, so I'm going to share my screen.
Okay.
Okay.
Okay. Naveen, you're muted. We can't hear you.
Can y'all hear me now?
Yes.
Loud and clear.
Okay. All right, let's just do it again. So my presentation is going to be about like the evolution of the universe. And firstly, let's get into it. Just a little bit of background information from the introduction. Around 15 billion years ago, the universe emerged from a hot, dense sea of matter and energy. So as the cosmos later cooled down and like expanded and got larger, it spawned many galaxies, stars, planets, and eventually life. So roughly like around 15 billion years ago, all of the matter and energy in the universe were concentrated into a single region smaller than the size of a dime today. Which it's if you see the size of it, it's insanely small. And you see all this matter from the universe, we don't know how big it is. And all of that is actually concentrated into like the size of a dime. That's what's like mind-boggling here. So the next slide is about firstly we need to know about like the formation, how it formed. And as everyone knows, the Big Bang Theory, of course. The universe began from extremely high density and temperature, and space expanded as the universe cooled. And then the simplest elements formed. Then gravity gradually drew matter together to form the first stars and galaxies today. And galaxies collected into groups, supernovas, and superclusters. And next one. And this is like the very early universe. So after the formation of the universe from the Big Bang, the universe was like a hot superparticles for reference. So when the universe began to cool, the protons and neutrons started combining into ionized atoms of hydrogen and helium as we know today. And next, we go on to the dark ages of the universe. And this period, just for reference, measures from 370,000 years to about 1 billion years ago. And after recombination of the decoupling, the universe was transparent, but the clouds of hydrogen collapsed very slowly to form our stars and galaxies, meaning no new sources of light were available. Go on next. Structural emergence. So at some point around 200 to 500 million years ago, approximately, the earliest generations of stars and galaxies formed. The large structures began to gradually merge, drawn with the foam-like matter events drawn throughout together in like the universe. So as we go on next, we go into our present-day universe. The present-day universe is like a mix of the collection of galaxies, star clusters, and nebulae surrounding our world. And there's many instances of like exotic phenomena such as black holes in general. And as we go next, we're going to look at the future of the universe. So the future of the cosmos is still yet to be determined, but like right now there's a theory that in 100 billion years all galaxies will be so far away from each other that they will be not visible with even telescopes for viewing. Between 100 billion and trillions of years from now, star formation will gradually slow down and come to a halt eventually. And as our conclusion, we conclude, therefore, the universe has a cause of its existence. And just some pics from the total solar eclipse. This is just one pic that we just took
Very
from this.
nice.
Next one. These are just some like of shots from our telescope that we took.
Is this through the interstellar?
Yeah, this was through the interstellar. Yeah, with like a
Uh-huh.
solar filter and stuff. And next one, these are just some shadows, some fun shadows from the driveway and stuff. So just the
Yeah.
tree shadows right here. You can see all the eclipse stuff. And I was going next.
That's a
These are
great
just-
way to see the eclipse. If you don't know what's happening, you see
Yeah.
those in the shadows and you go, we're having an eclipse.
Yeah, it's a fun thing to do. It's a very fun and easy thing to do. And the next, these are just some rough iPhone shots.
Wow, those are
Just
really good.
from the driveway. Yeah. And
You got
just
clouded out too, huh?
That was our
yeah,
experience
Dallas got clouded
you were
out.
there.
in Texas as well, but we
Yeah,
did see it,
Dallas.
you know, so.
Yeah, at least we could
Yeah,
see
that's a
that.
good view.
Yeah, so we got this, we got this. This is the totality, and then this is just a partial. And then just some outreach just going on. Just called some people over to home, and then just put up a few telescopes and then public viewing, just in general. Just local neighborhood and stuff. So yeah, for this part. And just some more outreach, just some kids viewing. They got fascinated from the eclipse, just from looking at through the eclipse glasses.
Mhm.
It's a person looking through our Explore Scientific telescope. And then we have some more people looking through the same Explore Scientific telescope, as you see. And everyone else here, everyone that came to the event were like in total awe of like what's going on, because they never really saw some sort of like event like this happen like in their life so far.
Sure.
That's what many people said. So thank you. That's all. That's all I have for today.
Thank you very much, Naveen.
Nice.
Thank you.
Good job.
Okay.
Thank you.
Thank you. All right. So our next speaker is Mirko Mayer. And Mirko is you've been on one time before, as I recall. Is that
Yes.
right?
Yeah. Mhm.
Uh-huh. Okay. All right.
Yeah,
And so you know, I've learned more about you. Of course, John talks about your astronomy adventures and you guys with your big reflectors. You know, you mentioned today that you have a 32-inch Dobsonian that you like to use. Um,
Yes.
I imagine you have to climb up a tall ladder to get up to the eyepiece. Is that right?
Actually, it's 32 f3. So for much of the night,
F3.
we
Oh,
can
goodness.
we can
Wow.
stand, just on our feet, maybe one step or two steps for
I see.
ladder. John's certainly been an inspiration on me diving into this big aperture ownership. I couldn't have done it without him. So kudos to that.
Yeah.
And yeah,
That
so
scope is rock solid in the wind
yeah,
too. Being short like that, it
yeah.
really combats the wind.
But yeah, Scott, thanks for having me on, and it's an honor and a pleasure to be on
Oh,
your
thank you.
150th episode. So
Thank you. That's great.
I'm just gonna be real quick. All I want to
Yeah.
do is really what's been touched on previously and earlier, and what an amazing presentation from Kareem and Nathan and all the other speakers. That
Oh,
was
yeah.
a lot of
Sure.
fun listening to them. Especially got to get Nathan's book. It's pretty eye-opening, and I love the perspective of that. That's what got me into this hobby,
Oh,
was
yeah.
really the perspective of looking up and
Mhm.
understanding your place in the cosmos. But yeah, I was going to go over a lot of what was shared already about that amazing Aurora event on May 10th and 11th. And let me share my screen, see if I could share my screen here. Let's see, screen one. So so every new moon, Scott, we try to get out with our telescopes,
Yeah.
get together, and we really appreciate the dark skies. Where I'm from in California, Southern California, you have to go a ways to get to the dark skies.
Yeah, you do.
And so this outing took us to Wonder Valley, which is just north of Joshua Tree.
Okay.
And we went I had a friend come from out of town, and he wanted to go to Joshua Tree National Park, do some
It's dark out there.
photography, and have him look through a large scope. So this is just sharing this kind of what it looks like out there. It's really in the middle of nowhere, so you can get away from the lights of Los Angeles and everything.
So did you guys know you were going to have this Aurora, or what happened?
Yeah, so this is just basically what I'm going to do, is just share this experience. We were not chasing any Aurora, and all we were trying to do is just get to a dark site and use the telescope, John. And so
Yeah.
we just went to Wonder Valley, and the first night we set up, my friend wanted to go check out Joshua Tree. So we went to Pioneer Town a little. We saw this really cool car, and then we went into the park. And so this is the first night where we're, you know, getting the golden hour and trying to get some trees and some pictures. And he wanted to do some Milky Way photography, and just thought I'd share here a couple of shots here of the Joshua Tree and the park. And then this is one of my final edited shots here for with the southern sky Milky Way with the landscape of Joshua trees. And that big glow right there is looking south. So
we're not seeing it, your screen. You're not sharing.
We haven't seen anything.
Well, we saw him.
Well, you.
We saw
all
Mirko.
right. Can you see this?
Not yet. You have to hit the green button. It says share screen, and then you have to commit to it.
There we go.
Oh, that's
okay.
wow. Wow.
Okay, here, let me take you back to the.
Yeah, let's go back.
So here's the big 32 set up in Wonder Valley. There's really nothing around. So you didn't probably see where I was sharing this. So yeah, we're set up in just north of Joshua Tree.
Okay.
In Wonder Valley. Wonder Valley's here, and I would say it's a Bortle 3, Scott. It's not dark,
Okay.
but it's close. G Mars has a site out there with a bunch of telescopes.
Well, I've been out to G Mars before.
Yeah, we set up there. It was nice and warm and comfortable. Then we did a tour around Pioneer Town, got this really cool car.
Oh, that's cool.
And then these are the shots of the golden hour in the park.
Wow.
Yeah.
Those trees are amazing.
Tree arms.
Yeah. And so what I wanted to show was just one of my
that's an outrageous shot.
Too bad Adrian couldn't see that.
Yeah, well,
he's probably watching it.
Yeah, this is this
really
big glow here, like how Adrian talked about the light pollution, how far and what it looks like and what it does. But this big glow right here is Palm Springs, and it's funny because it almost looks like the Milky Way is crashing into the earth.
Yes.
Like there's an explosion or something.
Yeah, that's the explosion. That's right.
Yeah. But this is pretty cool. This is the prancing horse, the nebula right here, Rho Fuchsi. But I want you to remember what this looks like right here is this was a clear night, right? And now I'm going to move into our second night. Okay, this one more shot of the Joshua Tree
That's
here.
Cool.
Okay, and so in the second night, the moon is setting. This is just cell phone shots of the moon through the eyepiece. So
it's really good.
And then some with some earth shine.
Beautiful.
Here's a shot with the moon showing the earth, earth shine.
Was that with the 32?
Yeah, 32 with an Explorer 30-inch eyepiece, Explorer Scientific, and then I'm just holding the cell phone camera up to it.
Yeah,
that's amazing. Really good earth shine.
And then less exposure to get more of the. Okay, and so then when we were, then we were, waiting for it to get dark, and then all of a sudden we saw, this right here. Now we're looking north, okay, and then here's the Big Dipper. This is the Big Dipper, and then this is the handle of the Big Dipper.
Oh, okay.
And so while we were looking north, we were seeing this, like you could sort of see, because this is Las Vegas.
You saw it first, didn't you see the red light? And they were saying, no, there's no red light.
No. What we did was we noticed some striations, and we were setting up our cameras, and then next thing I knew, I took a test shot, like 40 degrees up in the air, and I saw this very deep red hue, and I said, gentlemen, I think we're getting some form of aurora. And then my friend jumped online, confirmed it, that there were some reports of aurora heading in, and this was the night. This was probably just right after sundown on
May 11th,
on the 10th. So
10th.
This is before we decided to really get. So basically, we're 30 minutes from the park, and we started seeing all of this go down. And we took these. This is actually my camera shot here. But some of these are going to be.
Oh wow!
This is my DSLR camera. So after seeing that, what we decided was to run back into the park and get pictures of these Joshua trees with the aurora.
Yeah.
It's
And
beautiful, Mirko.
just sharing a couple shots here.
Oh,
Look at that.
man.
That's like a postcard. That's great.
Yeah, that is brilliant.
Yeah.
Yeah, so we were really just at the right place at the right time. We were not trying to chase any of this. And here's a shot with the Milky Way going into the aurora. But this is,
That's cool.
Scott, it's so unprecedented that we were able to capture this from so far south.
I know.
Here's Cassiopeia right here, right on the horizon.
Yeah.
And then I think
Mount
that's
Wilson, years ago, Mount Wilson had an auroral display, which was just kind of a reddish glow. And of course, this is before smartphones and stuff. So this was actually seeing this with the naked eye, and people thought that a fire was coming, you know.
Yeah.
So, yeah.
During the night, we could actually, I find out that some people are more sensitive to color than others.
That's true.
But I was able to see the red haze by, you know, getting into the Milky Way. It sort of looked like a brownish kind of haze, almost like if smoke were in that portion of the sky.
Right.
And then so what we did, Scott, I turned the camera south, and this is how far south the this glow went. So I saw multiple pictures of this red hue, and I was like,
red.
that just it seems
It looks fake.
It's hard not to make it look fake, right? But what I was doing
Now,
here,
okay, so the red glow that's on the ground, this is also
it's
illuminated by this aurora.
Man.
Is that right?
Yeah. But here's what I want to share. Also, what I found out about this, Scott, is that maybe for our scientific and academic guests to better explain, I understand that aurora, you know, it's basically ionization or particles being charged in the upper atmosphere from the solar activity, right? But what this phenomenon is I've learned that I've looked on spaceweather.com here, and let me see if I can. It's actually, they're saying that this is a new kind of phenomena that's being studied, and they're saying that these things occur during large geomagnetic events, but it's the mechanisms are different than what is a typical aurora. They're saying that this is caused by kinetic and thermal effects of the atmosphere and it has to be very, very, very high, but it's kind of a new phenomena.
Interesting.
And I've also been just Googling this here and there, trying to learn. And from what I've seen is that here's
hot
another
plasma flow. Okay.
Yeah, so this is so what happens is it turns into an arc, what's called a stable aurora red, an SAR, turns into a Steve. And a Steve stands for, hold on, let me get it. Thermal emission velocity enhancement.
Steve, how are you?
Yeah,
So I think what happened
we had a
this
guy
night,
on before showing some Steve.
What I think happened this night was basically this, and it became this. It just stayed there all night. This whole
that's wild.
Stayed there in the upper atmosphere.
Yeah.
And this is another one without the trees illuminated, but you could see how far south. I mean, I'm looking south here.
You know what it looks like from my film imaging days, using actual film, it looks like it was like somebody opened up the camera and accidentally.
Yeah, like a reflected light.
Yeah.
Mm-hmm. With the Joshua trees.
Yep. So pretty.
Oh, wow. Beautiful.
Yeah.
And these right here are cell phone shots. I want to show you this. I have a time lapse somewhere here. Here it is. And you could see these with our eyes. These columns coming up out of the sky. These were viewable with our eyes, just kind of like a hazy yellow glow, very kind of faint, but you could see that. But yeah, we were just, what a fortunate time. You know, all of us on the planet viewing this were just
Yeah.
pretty fortunate and unprecedented event. And you know, they're
There were a
talking
lot
about,
of, I noticed that just in general conversation, you know, I go to the grocery store or whatever, and I heard people kind of talking about, you know, getting out to try to photograph these aurora, you know, and I thought that this is cool. You know, this is a sky event that brings a lot of people together. And,
Mhm.
you know, the average person's, I mean, totally interested in this stuff. So this is great.
Yeah. This is just shot time lapse again, looking pretty much straight up, and this is towards the end of the night, so the it got less red, I guess. And this is, you know, this is Vega, pretty high up in the sky.
Mm-hmm.
I mean, I would say that this was at least reaching 45 degrees, 50 degrees up in the sky, but it even went further on towards the south side of the Milky Way
Wow.
from our vantage point.
Yeah.
So that was pretty cool. And that's all really I wanted to share. Thank you for
Well, I'm glad you did. That's
letting me
really
share
great
that.
stuff.
Nice job, Mirko.
Wonderful. Wonderful. All right. All right. Well, Mirko, thanks again for coming on and sharing your work. And, you know, I certainly look forward to having you on in the future so you can share some more. So that's great stuff.
Man, Mirko, can you show that 45-65 you took of 30 through the 32?
Oh gosh, I don't know if I have it handy. It's buried
All right.
somewhere. Yeah, I'll try to dig it up.
You know, Mirko takes pictures. He was telling me one night years ago, he goes, we can take pictures with these big Dobbs. It's doable.
Yeah.
Everybody said it's not, but you know what? Mirko proved him wrong. It is doable.
Oh no,
Mirko's done some incredible shots of 51, 101.
45, 6. Can you see this
40.
one here?
That's through your 32 inch?
Yeah, zoom in on that a little bit.
Yeah, it's a little
Now,
soft.
don't, Mirko, don't tell me this is done with your smartphone, right? This is
No.
This is Astro cameras.
This is this is an Astrocam. Yes.
Okay. All right.
So, yeah, an ASI one-shot color with I believe it was 10-second to 15-second exposures.
Okay.
And stacked about like 45 images. So I think that totals about, oh gosh, like 10 minutes or 15 minutes or
You
something.
can see the gravity wave of that. There's like a gravity wave going through there. That's an amazing shot. Jeez.
It's amazing. It's good stuff.
I'll go ahead and pass it off to John, who's doing.
Okay. All right, John, we're going to give you the stage, man.
Well, I don't know. My presentation might not be nearly as good as that.
Well, you have that kind of pinkish, purplish, reddish.
Yeah, you are the Aurora.
Light on you. So.
The sun came out again today. It hasn't been out in weeks, and today it decided to come out. So it's a little warm in here actually, but I think I'll be okay.
Okay.
So yeah, you know, ironically, I had some pictures as well because Andrew was with Mirko, and so he sent me the pictures, and he was giving me a play-by-play when Mirko was out at the Joshua Park and taking those pictures, and I was like hating it that I didn't get to go because they really had a great night that night. So, but anyway, so we're talking about cell phone snapshots. So this is actually through Mirko's telescope. My friend Wayne took this picture, and this is the Eagle Nebula. And to tell you, you can see the pillars of creation even with a cell phone snapshot.
Oh yeah. That's beautiful.
Is that it? You have to admit that is something amazing to see that right there.
Nice. Yeah.
And that telescope is amazing. It's a fast telescope and it's super sharp, and it gives you the most amazing deep sky views. This was a cell phone snapshot. I'm not sure if that was through Mirko's scope or a C14 Edge. Probably the Edge because it's not near.
Is that 891 or?
Yeah, 891 through a cell phone.
Wow.
Another
That's cool.
shot. 253. Cell phone.
What?
Yep. Cell phone snapshot
That's cool.
through Mercoscope. through the what is it? The bat. The
I wish I
big.
could take this image and like go back in time just a little bit, okay?
No.
Our smartphones existed, of course, and show some friends that were spending thousands of dollars on astrocams and showing them these images, which would have blown them away.
Can you believe this? Of course, I
mean,
played with processing a little bit, but
it's amazing what technology, how what you know. I'm just watching these
okay, let me go
presentations
back.
with the
Oh yeah, and then to go back some more years, a few decades,
Yeah.
and show the
It
guys
was
at Palomar, that were
pan
running the
film.
200-inch. What amateur astronomers are doing with a phone and a amateur telescope. Okay,
Yeah.
they would not have believed it.
I mean, 253 with that kind of detail with the cell phone, that, I mean, that looks better than what you're seeing. Well, not necessarily through the big scopes, but I mean, that's very much what you're going to see in the big scope and some, right, Mirko?
Yeah, it's beautiful. Yeah, that's
So now I'm going to go on to my drawings. I'll try to put stuff up good like Mirko's work, because those were beautiful, Mirko. Really good work. Unbelievable. This is M106 as it would look through the telescope. And I'm blessed because I get to look through Mirko's 32 when we're together, and also the 28. And the galaxies, the bigger is a little better. And globs, more light gives you a better view. This is the sunflower, my latest. So this is M63. And you've seen that one before, right, Scott? The sunflower?
Oh yeah.
But I mean, that's as good as you're going to see it, right, Mirko? And the big Dobbs.
Oh, sorry, I was on mute. Yeah, I mean, it's a great representation.
104 sombrero. That was another version of one of my sketches. It was in a warmer tone. We get some really good views of that. This was a sketch of the eagle that I did. Having these big scopes, it makes a big difference. This is my latest ring nebula. Again, with the big scopes, we look at that central star quite often, especially in Mercoscope. You can see it straight away, right? Dumbbell. This one I love because it reminds me of the Castaway, the movie, the box with the wings.
Oh, that's pretty cool.
The death of a star, and the view that I had was through the 9mm 120 Explorer. That was just stunning. That revealed those wings. I mean, that eyepiece, it just opens up the sky, and the dumbbell filled the whole eyepiece. It was probably one of the most amazing views of the dumbbell I've had. Just,
that's great.
Seeing it like that it's not even real almost. It's so good. Now, this was from their site. This is Andrew's picture, Mirko. This is a good one. He was like telling me during the whole thing, he goes, yeah, those guys are out there taking pictures at Joshua Tree and they're all motivated, and I'm here alone with the 32. He did some amazing sketches through that. Look, you can see the stars peeking through there. Here's another one that that he took. These are probably similar to what you were getting, right, Mirko?
Yeah,
that's like that last one you were showing. The beautiful transition of blue and pink. That looks really good. That must have been a great sight for you guys.
Yeah,
this one's really cool. This is Andrew's scope looking up. I thought that was real nice.
That's cool.
Yeah. That was he's proud of that one. He likes the silhouette scope a lot. because, you know, I actually sold him that telescope. It's a very good telescope. And he gets full use out of that and does some amazing sketches with it. And with the 16 that Mirko has, the Explore Scientific, and the 14, they were spending one night just using the 16 and the 14 and having a great time, getting all kinds of amazing views, right, Mirko?
Yeah, that night we saw my farthest object I've ever seen, which was a quasar. Forget the name it was, but 10 billion light years.
Dang.
And that was with the 16-inch scope, or?
No, that was with the 32.
Wow. Well, I'm moving on. My son graduated honors. You know, I always took him to the Mount Pinos and studied astronomy a lot with me. Actually helped demo Hal Jandorf's observatory from Moore Park College when he was a little kid, and went to a lot of public star parties. He graduated with honors, summa cum laude. Very proud. The science and astronomy and art, it all paid off. Mathematics, he used it very well, and he's applied himself, and now he's graduated college. Very proud. Of course, I always like to show a couple of my little observing buddy, my little partner, Bosco.
Hey, Bosco.
He's got a new haircut. That's his new bandana they give him a new bandana every time he gets a cut.
Mm-hmm.
He works out too. You can see the legs on him. He's
buff.
We take 2 walks a day, every day. This dog, he don't mess around, man.
Right.
Of course, I love to show a couple flowers, always taking the time to realize the beautiful things that are all around us every day that a lot of times you don't really look at because you have so much going on. But if you just stop for a second and smell the roses, man, it'll really give you a little bit of comfort and calmness. These are just flowers on my walk with my dog that I come across that I'm so blown away by the color and the way they're blooming so beautifully. I like to share them with all of you. These are just right in the neighborhood, you know. Look at those beautiful reds. Unbelievable views.
Yeah.
And closing with my little friend.
It's nice to live in the corner of the universe where flowers bloom, you know, so.
Yeah. I mean, the colors are absolutely amazing. And, you know, just like some of those carbon stars and those beautiful nebulas and the auroras, those colors are very reminiscent all across the globe, you know, and throughout the universe. I'm even have a warm glow to me right now, as a matter of fact, but it'll be cooling off soon.
Yeah.
Well, that is my presentation, and
right.
thank Mirko.
Well, I appreciate it. I appreciate
Beautiful.
it.
What a great show tonight. Everybody
Yeah.
was such a great group of people, and knowledge and amazing pictures and fun stuff. I've had a real good time. Thank you so much.
Yeah,
Thanks,
it was
Scott.
wonderful
Appreciate
to
it.
celebrate our 150th with all of you, and
Yeah.
those presenters that are out there still watching, you know, thank you very much for coming on. We had a total, I think, of 14 of us, something like that. So, actually, Iker could not finish his presentation, but he was there, so I'll still count it. Okay. And I want to thank the audience for tuning in and watching us from around the world. We had people from South America, the UAE, North Africa. So it was fun. It's fun to know that you have people watching from around the world. And, you know, of course, we have a much smaller live audience, just like the TV series I Love Lucy, okay, which is now even today, the I Love Lucy show is watched by about 40 million people every day.
I think the aliens are watching it too, because
We're
that
talking
signal.
black and white, filmed in front of a live audience of about 300 people. Okay, and that was a big show back then. Okay, but a lot of the live shows get not so many live audience. Maybe like if you go to Burbank and you watch a live show, you're going to be sitting in an audience of maybe 25 to 50 people, something like that.
Mhm.
You know, but
Mostly those Tonight Show and those hosted shows are where
yeah.
you do that now, but I don't think they do like the old days really much.
No, you're probably right about that. That's right.
Yeah.
So, yeah, but I'm gonna try to get a laugh track in here sometime, and, you know,
Yeah.
huge audience going nuts, you know, clapping and
Have some
going
canned,
crazy.
yeah,
But,
some canned applause.
anyhow, but you know, you can tell we have fun on Global Star Party, and it's because we're all friends, and it's nice to make friends with you out there in the audience too. So I've got a couple of little videos that were supplied. I think both of these from NASA, and
Very cool.
I'll leave you with that, and then we'll close out the show. But thank you so much for watching Global Star Party, and let's see. We'll do it just like that. And
Thanks,
we'll
Scott.
start off with this one right here.